Let's explore the git pull command. This command is used for fetching and merging remote changes in Git. Git pull is a Git command used to fetch and download content from a remote repository and immediately update the local repository to match that content. It combines the functionalities of the git fetch and git merge commands into a single convenient command. You should use git pull when you want to update your local branch with the latest changes from a remote branch. It is recommended to use it before starting new work to ensure you have the most up-to-date code. Also, make it a part of your regular development workflow to keep your local repository synchronized with the remote repository. Let's understand what happens behind the scenes when you run git pull. First, the git fetch command retrieves the latest code, including new commits, from the remote repository. Second, the git merge command integrates these fetch changes into your local repository, updating your working copy. So, git pull is essentially a two-step process of fetching and merging. Here's the basic syntax of the git pull command. It is git pull, followed by optional arguments like options, repository, and ref spec. Here are some common examples. To pull from the current branch's tracking branch, simply type git pull. To pull from a specific remote in branch, use git pull origin main, replacing origin with the remote name and main with the branch name. To pull with rebase instead of merge, use git pull rebase. Let's see some common examples of using git pull. The basic command git pull fetches changes from the remote branch that your current branch is tracking and merges them into your local branch. The output will show the files updated and the number of insertions. To pull from a specific remote in branch, use git pull origin develop. This fetches changes from the develop branch on the origin remote and merges them into your current branch. The output confirms the branch from which changes were fetched and the files that were modified. Now let's explore some advanced options for git pull. To pull with rebase, use git pull rebase. This rebases your local changes on top of the fetch changes, creating a linear history, and the output shows the commits being applied. To pull with specific options such as fetching from origin main, but not automatically committing the merge, use git pull nocommit origin main. You can also configure the global pull behavior by using command git config global pull.rebase true. To perform a dry run which shows what would happen without actually making any changes, use git pull dry run. Sometimes, when you pull changes from a remote repository, you might encounter merge conflicts. Here's an example of a conflict in a file. The lines between ahead and represent your current changes, while the lines between and origin/main represent the incoming changes from the remote repository. To resolve the conflicts, first, edit the file to resolve the conflicts by choosing which changes to keep. Then, add the resolved files using the git add command, and complete the merge by using command git commit. Here are some best practices and tips for using git pull. Always pull before pushing to avoid unnecessary merge conflicts. Commit or stash your local changes before pulling. Use rebase for a cleaner history in shared branches and set up pull.rebase in your Git configuration for consistency. Avoid pulling with uncommitted changes that conflict and avoid force pushing after pulling on shared branches. Do not ignore merge conflicts. Resolve them properly and avoid pulling directly into production branches without testing. In summary, the git pull command combines fetch and merge in one command. Use the rebase option for a cleaner, linear history. Always commit or stash your local changes before pulling. Resolve conflicts by editing files and completing the merge, and keep your repositories in sync with git pull. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Let's explore the git push command. Git push is used for uploading local changes to remote repositories. We will learn what exactly it is and how it is used. So, what is Git push? Git push uploads the content of your local repository to a remote repository. It essentially transfers commits from your local repository to the remote repository, and it updates references such as branches and tags on the remote repository. The basic syntax of Git push is as follows: Git push followed by the remote name and then the branch name. A common example is Git push origin main, where origin is the remote repository and main is the branch you're pushing to. Let's take a look at the Git push workflow. First, you make changes to your local repository. This involves adding files, modifying them, and committing your changes. Second, you run the command git push to upload these changes to the remote repository. Finally, Git transfers your commits, updates remote references, and branches to reflect the changes you've made locally. In short, changes are made locally and then pushed to the remote repository. Let's see some basic Git push examples. The first example is push to default remote branch. The command git push origin main pushes commits from your local main branch to the main branch on the remote repository named origin. Second example is push to current branch. The command git push pushes the current branch to the default remote, which is usually origin, but only if an upstream branch is configured. Third example is push all local branches. The command git push all origin pushes all of your local branches to the remote repository. Now let's see some advanced Git push options. The first example is push tags. The command git push origin tags pushes all of your tags to the remote repository. Second example is force push. The command git push force origin main forces the push, even if it results in a non-fast-forward merge, potentially overwriting the remote history, so use with caution. Third example is push to different remote branch. The command git push origin local branch. Remote branch pushes your local branch to a differently named branch on the remote repository. Now let's explore common Git push errors and their solutions. First common error is rejected non-fast forward. This happens when your local branch has diverged from the remote branch. To solve this, first run git pull origin main to merge the remote changes into your local branch, and then run git push origin main to push your changes. The second common error is no upstream branch. This error occurs when the current branch does not have an upstream branch configured. To solve this, use git push, set upstream origin feature, replacing feature with your branch name. Alternatively, you can use the shorter form, git push uorigin feature. Now let's discuss some best practices for using git push. Step 1 is pull before push. Always run git pull before pushing to avoid conflicts with remote changes. Step 2 is review changes. Use git status and git diff to review your changes before pushing. Step 3 is push small batches. Try to push small logical sets of changes rather than large unwieldy batches. Step 4 is verify push. After pushing, check the remote repository to confirm that your changes were pushed correctly. Here are some helpful tips and important warnings for using git push. Some helpful tips are: use git push uorigin branch name to set up tracking for new branches. Configure git config global push.default current to simplify pushing. Use SSH keys instead of passwords for more secure authentication. Create aliases for common push commands in your Git configuration to save time. Important warnings: avoid using force unless absolutely necessary, as it can overwrite others' work. Never push sensitive data or large binary files to public repositories. Be careful when pushing to shared branches in collaborative projects. Always check your .gitignore file to prevent pushing unwanted files. In summary, Git push is essential for sharing your work and maintaining remote repositories. Understanding its options and best practices is crucial for effective collaboration. Some key points to remember are: the basic usage of git push origin main uploads your local commits to the remote repository. Always pull before pushing to avoid conflicts and rejected pushes. Explore advanced options like tags, U, and all for specific needs. For further learning, you can refer to the official Git documentation, interactive Git tutorials, and Git cheat sheets. Happy coding! If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Let's explore Git remote management. We will learn about adding, removing, and renaming remote repositories. This is essential for collaborating on projects and managing your code effectively. So, what exactly are Git remotes? Remote repositories are versions of your project that are hosted on the internet or on a network. They enable collaboration with other developers, serve as a backup for your local repository, and are commonly found on platforms like GitHub, GitLab, and Bitbucket. Remote operations involve adding remote connections to other repositories, pushing changes to remote repositories, pulling changes from remote repositories, and managing multiple remote connections. Now let's see how to view remote repositories. To list all remote connections, use the command git remote. To view detailed remote information, including the URLs, use the command git remote-v. This will show you the names of the remotes and their corresponding URLs for fetching and pushing. Next, let's discuss how to add remote repositories. To connect your local repository to a remote repository, use the command git remote add name repository URL. The name parameter is a short label you'll use to reference this remote. For example, to add a GitHub repository as origin, you would use the command git remote add origin followed by the repository URL. To add a second remote as upstream, which is common for forks, you would use the command git remote add upstream followed by the URL of the original repository. Now let's see how to remove remote repositories. To disconnect from a remote repository, use the command git remote remove name. For example, to remove the remote named origin, use the command git remote remove origin. Alternatively, you can use the shorthand command git remote rm name. For example, to remove the remote named upstream, use the command git remote rm upstream. Let's explore renaming remote repositories. To change the short name of a remote repository, use the command git remote rename old name new name. For example, to rename the remote from origin to primary, use the command git remote rename origin primary. After renaming, you can verify the change by checking your remotes using the command git remote-v, which will display the updated name. Now let's see how to change remote URLs. To update the URL of an existing remote, use the command git remote set-URL name new URL. For example, to change the URL of the origin remote, use the command git remote set-URL origin followed by the new URL. This is useful in situations like repository ownership transfer, switching from HTTP secure to SSH, migrating to a different Git hosting service, or when a repository is renamed on the remote server. Let's discuss some best practices for remote management. Use descriptive remote names for multiple remotes. Regularly fetch updates from all remotes. Verify remote URLs before pushing important changes. Consider using SSH URLs for better security. Document remote setup for team collaboration. Use upstream remotes when working with forked repositories. Effective remote management is essential for collaborative Git workflows. Master these commands to work efficiently across multiple repositories. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Let's explore remote tracking branches. These are essential when collaborating on projects using Git. This presentation will help you understand how to work with branches that track remote repositories, enabling you to collaborate effectively with others. Let's define what remote tracking branches are and their purpose. Remote tracking branches are references to the state of branches in remote repositories. They are typically named like origin/main or origin/feature. These branches represent the state of a branch on the remote repository at the time of your last communication with that remote. The remote tracking branches are updated when you communicate with the remote repository, such as when you fetch or pull. The purpose of these branches is to track changes in remote repositories, allow you to work offline by providing a local reference, provide reference points for synchronizing your work, and enable collaboration across distributed teams. Now let's discuss how to view remote tracking branches. You can list all remote tracking branches using the command git branch r. This will display a list of remote branches, such as origin/main, origin/feature-login, and origin/bugfix123. To list both local and remote branches, use the command git branch a. This will show your local branches like main and featureauth, as well as the remote branches under remote/origin/. Understanding how to view these branches is crucial for managing your Git repository effectively. Let's explore how to create tracking branches in Git. There are two primary methods to achieve this. The first method involves checking out a remote branch, which automatically creates a local branch that tracks the remote branch. For example, using the command git checkout feature-login, we'll create a local branch named feature-login that tracks the feature-login branch on the origin remote. The output confirms that the branch is set up to track the remote branch and switches you to the new local branch. The second method is to explicitly set up tracking for an existing local branch. To do this, you can use the command git branch setupstream to equals origin/featureauth. This configures your current branch, for example featureauth, to track the remote branch featureauth on the origin remote. Alternatively, when pushing a local branch to a remote for the first time, you can use the command git push uorigin featureauth, which both pushes the branch and sets up the tracking relationship. Either of these commands set up the local branch to track the remote branch. Choosing the right method depends on whether you're starting from a remote branch or setting up tracking for an existing local branch. Let's discuss the relationship between local and remote branches. Consider the local main branch, which has commits 1 through 5. The origin/main branch, which is the remote tracking branch for main, only has commits 1 through 3, meaning it's behind the local main. Similarly, the local feature branch has commits 1, 2, and 4, while the origin/feature branch only has commits 1 and 2. The arrows indicate the synchronization points between the local and remote branches. This visualization helps illustrate how local branches can diverge from their remote counterparts, and how Git helps manage these differences. Let's explore how to synchronize your local repository with remote branches. First, let's look at fetching updates. Fetching updates remote tracking branches without altering your local branches. Use the command git fetch to retrieve updates from all remotes. To fetch from a specific remote, use git fetch origin. To fetch a specific branch, use git fetch origin feature-login. Now let's discuss pulling changes. Pulling fetches and merges changes into your current branch. If you have a tracking branch set up, then you can use git pull to pull from the tracking branch. To pull with rebase instead of merge, use git pull rebase. To pull from a specific remote and branch, use git pull origin featureauth. Understanding these commands is crucial for keeping your local repository in sync with remote changes. Let's see how to push your local changes to remote branches. First, the basic push operations. Pushing sends your local commits to the remote repository. To push to your tracking branch, simply use the command git push. To push to a specific remote and branch, use the command git push origin featureauth. To push and set the upstream tracking branch, use the command git push u origin feature auth. Now let's consider push options in scenarios. There are different push situations. To force push, which you should use with caution, use the command git push force. A safer alternative is git push force with lease. To push all branches, use git push all. Understanding these options is vital for managing your contributions to the remote repository effectively. Let's explore a typical development cycle with remote branches. The first step is to fetch. This involves updating your remote tracking branches with the latest changes from the remote repository. Next, you create a branch. This means creating a local branch from an updated remote tracking branch. The third step is work. This is the part where you make changes and commit them to your local branch. Finally, you push. Push your changes to the remote repository and set up tracking, if it's not already established. Following this workflow ensures a smooth and collaborative development process. Let's address some common issues that you might face when working with remote branches and how to resolve them. First, let's explore how to check branch status. Use git branch VV to show detailed branch tracking information, including whether your local branch is ahead, behind, or diverged from its remote counterpart. Use git remote show origin to display detailed information about the remote repository. Now let's look at some common issues and fixes. To remove remote branches that have been deleted on the remote, use git fetch prune. To reset your local branch to exactly match the remote branch, use git reset hard origin/main. But be careful, this will remove local commits. To fix branches that have diverged, try using git pull rebase. Knowing these troubleshooting steps can save you time and prevent headaches when collaborating on Git projects. Let's explore some best practices for effectively working with remote tracking branches. First, fetch regularly. Keep your remote tracking branches updated by fetching changes frequently. Second, use descriptive names. Name your branches clearly to indicate their purpose and ownership. Third, clean up regularly. Delete merged or obsolete branches both locally and remotely to keep your repository tidy. Finally, avoid force pushing, and use it sparingly and only when absolutely necessary, as it can cause conflicts and data loss. Following these practices will help ensure a smooth and efficient collaborative workflow. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. Let's explore GitHub pull requests. This is a collaborative workflow for contributing code changes. GitHub pull requests are essential for team collaboration on coding projects. Let us define what a pull request is. A pull request is a method of submitting contributions to a project. You can request that someone review and merge your changes into their branch. The purpose of pull requests is to inform others about changes you've pushed to a branch in a repository. This facilitates code review and discussion before merging the changes. Here is the standard pull request workflow. The first step is to fork repository. Create a personal copy of someone else's project to work on. Then create branch. Make a new branch for your feature or bug fix. After that, make changes. Edit, add, or delete files to implement your changes. And finally, create PR. Submit a pull request for review and discussion. Let's start creating a pull request with step 1. Navigate to the GitHub repository you want to contribute to and click the fork button in the top right corner. Then clone your forked repository to your local machine using the git clone command. Here are some sample commands. First, clone your forked repository by running git clone followed by the repository's URL. Next, navigate to the repository directory by running the change directory command, followed by the repository name. Finally, add the original repository as upstream remote with the git remote add upstream command, followed by the repository URL. Let's move on to the next step. First, create a new branch for your feature or bug fix. Use a descriptive name that reflects the changes you're making. Next, implement your changes, additions, or fixes to the codebase. Keep commits focused and descriptive. Here are some sample commands. First, make sure you're on the main branch by running git checkout main. Next, create a new branch with the git checkout command flag b and the branch name like feature/add login page. Make changes to files. Check the status of your changes by running git status. Add your changes by running git add dot. Commit your changes with a descriptive message by running git commit with the flag m and the commit message. Let's look at the final step. Push your branch with the changes to your forked repository on GitHub. Next, navigate to your fork on GitHub. You'll see a prompt to create a pull request for the recently pushed branch. Here are some sample commands. Push your branch to your fork by running git push origin and the branch name like feature/add login page. You'll see output like create a pull request for the branch name on GitHub by visiting followed by the URL. Click the URL to create your pull request or navigate to your fork on GitHub and click Compare and Pull Request. Here are the pull request form details you'll need to fill out. Provide a descriptive title like Add Login Page with Email Validation. Provide a detailed description, answering what this pull request does, the changes made, screenshots if applicable, and related issues. For pull request description best practices, clearly explain the purpose of your changes. Reference related issues using keywords like fixes, closes, resolves. Include screenshots for user interface changes. And mention any testing you've performed. Let's understand the pull request review process. First, there are automated checks. Continuous integration and continuous delivery pipelines run tests and code quality checks automatically when a pull request is submitted. Next, there is code review. Maintainers and team members review the code changes, looking for bugs, style issues, and improvements. Then, address the feedback by making the requested changes and pushing updates to the same branch. Finally, approval and merge happens once approved, and the pull request can be merged into the main codebase. Types of feedback include comments, which is general feedback that doesn't explicitly approve or request changes, and is useful for questions and suggestions. Request changes indicate that changes must be made before the pull request can be merged, and blocks merging until addressed. Approve indicates the code is ready to be merged and requires at least one reviewer before merging. Let's see how to update your pull request. After receiving feedback on your pull request, you'll need to make changes to address the comments. Here's how to update your existing pull request. Make sure you're on your feature branch by running git checkout followed by the branch name. Make the requested changes to your code. Add and commit your changes by running git add, followed by git commit with a message. Push the changes to update your pull request by running git push origin and the branch name. Keep history clean by considering using interactive rebase to clean up your commit history before pushing updates. Respond to comments by replying to each review comment to show how you've addressed the feedback. Let's look at the best practices and resources for pull requests. Keep pull requests small and focused on a single issue or feature. Write clear, descriptive pull request titles and descriptions. Include tests for your changes when applicable. Review your own code before submitting the pull request. Keep your branch updated with the main branch. Some additional resources are GitHub Docs, GitHub Learning Lab, and GitHub Command Line Interface. Pull requests are the heart of collaborative development on GitHub. Happy contributing! If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Let's explore the world of pull requests and how to review them effectively. In this session, we will learn how to provide valuable feedback and carefully assess proposed changes to a project. This is all about collaboration, learning and improving the overall quality of the project together. So, what exactly is a pull request? A pull request is essentially a way to submit your contributions to a project. You propose changes from a separate area, which could be a forked repository or a branch within the main repository. Think of it as a formal request to merge your code into the project's primary code base. The main purpose of a pull request is to enable thorough code review, spark discussion around the changes, and secure approval before any new code becomes a permanent part of the project. Let's walk through the typical pull request flow. First, a developer creates a branch. Then, the developer makes the necessary changes and commits those changes to the branch. Next, the developer opens a pull request, signaling they're ready for feedback. The team then reviews the code, discusses any potential issues, and suggests improvements. Finally, once everyone is satisfied, the changes are merged into the main branch. Why is reviewing pull requests so important? Well, there are several key benefits. First, it ensures quality assurance. Reviewing helps to catch bugs, identify security vulnerabilities, and make sure the code adheres to the project's standards before it gets merged. Second, it facilitates knowledge sharing. Senior developers can share their expertise, and junior developers can learn from the process. Third, it promotes collaboration. It encourages team communication and a sense of collective ownership of the code base. Fourth, it maintains consistency, ensuring a uniform coding style, patterns, and overall architecture. Fifth, it reduces risk by minimizing the likelihood of introducing regressions or breaking changes. Finally, it enhances documentation by creating a record of decisions and discussions for future reference. Remember, code review isn't just about finding bugs. It's about building a stronger team and a more robust code base. Let's break down the pull request review process into key steps. Step 1. Initial assessment. Begin by reviewing the pull request description and its overall scope. Verify that it addresses the intended issue or feature. Step 2. Code examination. Carefully analyze the code changes. Look for potential bugs, style inconsistencies, and areas for improvement. Step 3. Provide feedback. Offer constructive comments, make suggestions, and pose questions to the author. Be clear and specific in your feedback. Step 4. Approval decision. Based on your review, either approve the pull request, request changes, or provide additional feedback as needed. Remember to approach code reviews with a collaborative mindset. The ultimate goal is to enhance the code, not to criticize the developer. When reviewing a pull request, what should you focus on? First, consider functionality. Does the code effectively solve the intended problem? Are there any overlooked edge cases? Is there proper error handling in place? Are there any potential performance bottlenecks? Second, assess the code quality. Is the code readable and maintainable? Does it adhere to the project's style guidelines? Is there any unnecessary complexity? Are there any code smells or anti-patterns present? Third, check the testing. Are there appropriate tests for the new code? Do existing tests still pass with the changes? Is there sufficient test coverage? Are edge cases adequately tested? Finally, examine the documentation. Are code comments clear and necessary? Is the pull request description detailed and accurate? Are any API changes properly documented? Is the commit history clean and meaningful? Providing effective feedback is crucial for a smooth and productive code review process. Let's start with the do's. Be specific. Point to the exact lines or functions and clearly explain your reasoning. Be constructive. Suggest improvements rather than simply highlighting problems. Ask questions. Use questions to understand the author's reasoning and encourage discussion. Prioritize issues. Distinguish between critical issues and minor suggestions. Now let's move on to the don'ts. Avoid being vague. Steer clear of general comments without specific examples or context. Avoid making it personal. Focus on the code, not the developer, and avoid using you statements. Avoid excessive nitpicking. Don't overwhelm the author with too many minor issues or stylistic preferences. Avoid assuming bad intent. Approach reviews with the assumption that everyone is trying their best. Instead of saying, "This code is inefficient. You should fix it," try something like, "The loop on line 42 might be optimized by using a map instead of a nested loop, which would improve performance for large datasets." Let's take a look at some code review examples to illustrate effective feedback. Here's the original code. The function calculates the total price of items in an array. However, there are some potential issues. Firstly, the function doesn't handle the case where items might be null or undefined, which could cause a runtime error. Secondly, consider using modern JavaScript features like const/let instead of var, and array methods like reduce for better readability. Thirdly, what should happen if an item doesn't have a price property? Should we skip it or treat it as 0? Now let's look at the improved code. The code now includes a check for null or undefined items, uses the reduce array method, and handles missing price properties by treating them as 0. This is a great improvement. The code is now more robust with proper error handling and uses modern JavaScript features. Next steps may include adding JavaScript documentation comments to document the function parameters and return value for better maintainability. Also, should we add type checking to ensure items is always an array when provided? Disagreements can arise during code reviews. So, how do you handle them constructively? First, clarify the issue. Make sure both parties understand the specific point of disagreement. Second, focus on principles. Refer to established best practices, documentation, or team guidelines. Third, consider trade-offs. Evaluate the pros and cons of each approach objectively. Fourth, involve others. If needed, ask for input from other team members or technical leads. Here are some communication tips to keep in mind. Be specific about your concerns and back them with data or examples. Listen actively to understand the other person's perspective. Consider switching to a real-time conversation if text communication isn't effective. Be willing to compromise when appropriate. Remember, the goal is not to win arguments but to produce the best possible code together. Let's summarize the best practices for pull request reviews. Review promptly. Aim to review pull requests within 24 hours to maintain team momentum and avoid merge conflicts. Provide iterative feedback. Offer feedback in small, manageable chunks rather than overwhelming the author all at once. Focus on impact. Prioritize issues that affect functionality, security, and maintainability. Be thorough. Review the entire pull request, including tests, documentation, and configuration changes. Adopt a collaborative mindset. Approach reviews as a partnership to improve code quality, not as gatekeeping. Embrace continuous learning. Use reviews as opportunities to learn and share knowledge across the team. Effective code reviews build stronger teams, improve code quality, and create a culture of continuous improvement. Don't forget to refer to team guidelines, code review tools, and pull request templates to streamline the process. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Welcome to this presentation on merging pull requests. In this session, we will explore the process of accepting and incorporating changes from contributors into a project's main code base. So, what exactly is a pull request? A pull request is a method for submitting contributions to a project, allowing team members to review changes before integrating them into the main code base. It essentially proposes changes from a feature branch, facilitates code review and discussion, and ensures quality control before merging. Think of it as a formal way to ask for your code to be included in the main project. Let's walk through the typical pull request workflow. First, the developer creates a pull request from their feature branch to the main branch, describing the changes and their purpose. Next, team members review the code, provide feedback, request changes, and discuss implementation details. Once the code meets quality standards and passes all checks, reviewers approve the pull request. Finally, the project maintainer merges the approved changes into the main branch, integrating the new code. There are primarily three methods of merging pull requests. The first is the standard merge. This creates a merge commit that preserves all commits from the feature branch in the main branch history. The command to achieve this is git checkout main, followed by git merge feature branch, and lastly git push origin main. The pros of this method includes preserving the complete history and avoiding the rewriting of commits. Next is the squash merge, which combines all commits from the feature branch into a single commit on the main branch. The command to achieve this is git checkout main, followed by git merge, squash feature branch, then git commit m, feature message, and finally git push origin main. The pros include a clean, linear history and a simplified changelog. The third type is rebase merge, which replays feature branch commits on top of the main branch, creating a linear history. To achieve this, run the command git checkout feature branch followed by git rebase main, then git checkout main, and finally git merge feature branch. The pros include a linear commit history and the preservation of individual commits. Now let's discuss how to merge pull requests on GitHub. First, navigate to the Pull Requests tab in your repository. Next, select the pull request you want to merge. Review the changes, comments, and check that all required checks have passed. Choose your preferred merge method from the drop-down menu. Finally, click the Merge Pull Request button to complete the merge. It is also possible to merge pull requests via the command line. First, fetch and check out the branch using the commands git fetch origin and git checkout b feature branch origin / feature branch. Then, verify the changes using git diff main feature branch. Next, merge the pull request by checking out the main branch with git checkout main and merging with git merge noff feature branch. For a squash merge, use git merge squash feature branch followed by git commit m merge feature branch. Finally, push the changes using git push origin main. When merging via the command line, it's important to always review changes locally before merging. Run tests to ensure the code works correctly. Use descriptive commit messages that explain the changes. Consider using merge strategies based on your project's needs, and delete feature branches after successful merges to keep the repository clean. Sometimes, when you're merging code, you might encounter a merge conflict. A merge conflict occurs when Git cannot automatically resolve differences in code between two commits. This happens when changes in the same part of a file conflict with each other. For example, if both branches modify the same line, a conflict arises. Git indicates which files have conflicts when you attempt to merge. Open the conflicted files in your editor to see the conflict markers. Edit the files to resolve the conflicts by choosing one version or combining both. Remove the conflict markers, which are represented by angle brackets and equal signs. Add the resolved files using the command git add and the file name. Then, complete the merge with git commit. To ensure the highest quality code, here are some best practices for pull request merging. Perform a thorough code review, ensuring at least one team member has reviewed the code before merging. Verify that all automated tests pass before merging, including unit tests, integration tests, and any other continuous integration and continuous delivery checks. Ensure the pull request includes appropriate documentation updates for any new features, application programming interfaces, or significant changes to existing functionality. Select the appropriate merge method, standard, squash, or rebase, based on your project's needs and commit history preferences. Delete feature branches after successful merges to keep the repository clean. And finally, encourage smaller, focused pull requests that address a single issue or feature. Good pull request practices lead to higher quality code and smoother collaboration. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Let's learn about working with forks. This is about contributing to projects using the fork and pull request model. You can see an illustration of the repository, your fork, clone and pull request to the repository. A fork is a copy of a repository that allows you to freely experiment with changes without affecting the original project. It creates your own copy of someone else's project. You have full control over your fork. Also, it maintains a connection to the original repository. In the diagram, you can see the original repository, your fork, other users' fork, local clone and pull request. Let's see the benefits of using forks. Firstly, it provides a safe experimentation environment where you can experiment with changes without affecting the original project, and try new features or fixes in isolation before proposing them. Secondly, it is a standard contribution model to open source projects where it allows project maintainers to review changes before merging. Thirdly, it helps in project customization where you can adapt existing projects to your specific needs and maintain your own version with custom modifications. Finally, it helps in project evolution where you can create new projects based on existing ones and take development in new directions while building on solid foundations. Here are the steps to create a fork. First, navigate to the repository you want to fork on GitHub. Second, click the fork button in the top right corner. Third, select your account as the destination for the fork. Fourth, wait for GitHub to create your copy of the repository. Fifth, you now have your own copy to work with. On the right side, you can see a GitHub user interface, highlighting the fork button with a dash circle. After creating your fork on GitHub, you need to clone it to your local machine to start working on it. To do that, open your terminal and type git clone followed by the URL of your repository. Then, navigate into the project directory by typing cd and the name of the project. Make sure to replace your username with your actual GitHub username and project with the repository name. On the right side, you can see the diagram of cloning of repository from GitHub to local machine. To contribute back to the original project, you need to set up a connection to the original repository, also known as setting up remotes. First, check current remotes by typing git remote-v. It gives you the origin, which is your forked repository URL. Then, add the original repository as upstream by typing git remote add upstream followed by the URL of original repository. The upstream remote allows you to pull changes from the original repository to keep your fork up to date. The diagram on the right shows the connection between your local repository, your fork which is named origin, and original repository which is named upstream. Let's look at the steps to make changes. First, create a new branch for your feature or fix using the command git checkout -b feature branch. Second, make your changes to the code. Third, commit your changes with a descriptive message using the commands git add dot and git commit -m followed by your message. Fourth, push your branch to your fork on GitHub using the command git push origin feature branch. A workflow diagram is also shown. Here are the steps to create a pull request. First, go to the original repository on GitHub. Second, click on Pull Request tab and then New Pull Request. Third, click Compare across forks and select your fork and branch. Fourth, add a descriptive title and detailed description. Fifth, click Create Pull Request. A good pull request description explains what changes were made and why they're needed. As the original repository evolves, your fork can become outdated. Regularly sync your fork to keep it up to date. To do this, first fetch changes from the original repository by typing git fetch upstream. Second, switch to your main branch using the command git checkout main. Third, merge changes from upstream/main into your main branch using the command git merge upstream/main. Fourth, push the updated main branch to your fork using the command git push origin main. Keeping your fork updated reduces merge conflicts when submitting pull requests and ensures you're working with the latest code. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. In this video, we're going to explore the .gitignore file, a crucial tool for managing your Git repositories. We will learn how to specify files that Git should intentionally ignore. Let's get started. What exactly is a .gitignore file? A .gitignore file is a simple text file that specifies intentionally untracked files that Git should ignore. This means that Git will not include these files when you commit changes to your repository. It's important to note that files already tracked by Git are not affected by the .gitignore file. Each line in the .gitignore file represents a pattern that Git uses to determine which files to ignore. Let's look at an example. In your repository, create a file named .gitignore. This file contains a list of common files that you might want to ignore, such as .log files, the node_modules directory, .ds_store files, .env files, and the build and dist directories. Now let's dive into the basic patterns you can use in your .gitignore file. Blank lines are ignored, allowing you to add space for readability. Lines that begin with a hash symbol are treated as comments, which you can use to explain your ignore rules. You can use standard glob patterns to match file names. End patterns with a / to specifically target directories. Use an exclamation point to negate a pattern, which means to specifically include a file or directory that would otherwise be ignored. Here are a few examples of how to use these patterns. *.txt will ignore all files ending with .txt. Logs / will ignore the entire logs directory. Build / will ignore the build directory. !important.txt will make sure that important.txt is not ignored. doc*.txt will ignore all .txt files inside the doc directory. Now let's explore some advanced .gitignore patterns. *.log will ignore all files with the extension .log. !error.log will make sure that error.log is not ignored. /todo will ignore the file name todo in the root directory, but it will not ignore the todo file in a subdirectory. Build / will ignore all files in the directory named build. doc/*.txt will ignore doc/notes.txt but not doc/server/arch.txt. Git uses glob patterns that are similar to shell wildcards. These patterns are matched relative to the repository root, unless a path separator, which is a /, is used. Next, let's discuss how to work with .gitignore files. To create a .gitignore file, navigate to the root of your repository in the command line, and then use the touch command followed by .gitignore to create the file. Then, open the file in your favorite text editor, such as Nano, to add your ignore patterns. Be sure to commit the .gitignore file to share the ignore rules with other collaborators. It is important to remember that the .gitignore file itself is typically tracked, not ignored. To check if a file is being ignored, use the command git checkignore followed by the file name. This will tell you if the file is ignored, and which pattern in the .gitignore file is causing it to be ignored. You can also list all ignored files using the command git status, ignored. If you need to force add an ignored file, you can use the command git addf file name. By default, Git will not show ignored files in the git status output. Git supports multiple .gitignore files at different levels of your repository. Patterns in higher-level directories affect subdirectories. The main .gitignore file is located in your repository root, is tracked by Git, and is shared with all collaborators. You can also place .gitignore files in subdirectories to have rules that only apply to that directory and its children. Finally, you can set up a global .gitignore file for rules that apply to all repositories on your machine, but are not shared with others. To set up a global .gitignore file, use the command git config global core.excludes file followed by the path to your global ignore file, such as /gitignore_global. Let's explore some common .gitignore templates. Here are some examples for Node.js. Node_modules directory, npmdebug.log, yarnerror.log, and .env. Here are some examples for Python. __pcache__ directory, all.pyc and .po files, all $poa.class files, venv directory and .env. GitHub provides templates for many languages and frameworks. You can visit github.com/github/gitignore for a comprehensive collection. Here are some examples for IDE and OS-specific files. For JetBrains IDEs, you can ignore the .idea directory. For Visual Studio Code, you can ignore the .vscode directory. For macOS, you can ignore .ds_store files. For Windows, you can ignore thumbs.db and desktop.ini. Add IDE settings to your global.gitignore file. Use gitignore.io to generate custom templates. Only include patterns relevant to your project. Here are some best practices for using .gitignore files. Commit your .gitignore file early, before adding other files to avoid accidentally tracking files that should be ignored. Be specific with your patterns rather than overly broad ones. Avoid ignoring entire directories unless necessary. Document your patterns by adding comments to explain why certain files are being ignored, especially for non-obvious patterns. Separate concerns by using a global.gitignore file for personal preferences, such as IDE files and OS files, and use repository-specific .gitignore files for project files. A well-maintained .gitignore file keeps your repository clean and focused on the essential code and resources. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. In this video, let's explore Git attributes files. We'll discover how to control Git's behavior using Git attributes, ensuring consistency and customization across your projects. So, what exactly is a .git attributes file? It's a text file named .git attributes that defines attributes for file paths in your repository. What's its purpose? Primarily, it's used to control how Git handles different file types, ensure consistent behavior across different environments, and customize Git's behavior for specific files. Let's break down the basic syntax of a .git attributes file. It uses a pattern-based configuration. Each line in the .git attributes file follows this format: pattern followed by attribute 1, attribute 2, and so on. For example, star.txt followed by the text attribute, star.jpg followed by the binary attribute, star.png followed by the binary attribute, makefile followed by text EOL equals LF, which means end of line equals line feed, star.bat followed by text EOL equals CRLF, which means end of line equals carriage return line feed. Any line starting with a hash is considered a comment. The .git attributes file is typically placed in the root directory of your repository. Let's explore some common Git attributes. Firstly, consider text handling. The text attribute marks files as text, enabling line ending normalization. For example, star.txt text. The binary attribute marks files as binary, disabling line ending conversion. For example, star.png binary. The EOL attribute sets a specific line ending style, which could be LF or CRLF. For example, star.sh text EOL equals LF. Next up, let's consider diff and merge behavior. The diff attribute specifies how Git generates diffs for files. For example, star.md diff equals markdown. The merge attribute defines the merge strategy for specific files. For example, star.db merge equals binary. And finally, the -diff attribute, which disables diff generation for binary files. For example, star.pdf-diff. One of the most common use cases for .git attributes is to manage line endings across different operating systems. Here's how you can do it. First, set the default behavior to automatically normalize line endings using the statement star_text equals auto. Next, explicitly declare text files with specific line endings, such as star.txt, text_eol equals lf, star.md, text_eol equals lf, star.ss, text_eol equals lf, star.js, text_eol equals lf. Files specific to Windows should use CRLF, such as star.bat, text_eol equals CRLF, star.cmd, text_eol equals CRLF. Binary files should not be modified. Examples include star.png binary, star.jpg binary, and star.pdf binary. This ensures consistent line endings, regardless of the developer's operating system, preventing unnecessary diff changes. Let's explore how to improve diff output. You can configure Git to use specialized diff algorithms for specific file types. Star.json diff equals JSON. Star.md diff equals markdown. Star.png diff equals EXIF. To set up custom diff drivers, define them in your Git config. For example, in .git/config or your global config, add the following: diff.json text convert equals python-mjson.tool. Diff markdown word regex equals open square bracket -z uppercase -z0-9 underscore close square bracket plus or open square bracket :space close square bracket. Diff exif text convert equals exif tool. The export ignore attribute prevents specific files and directories from being included when creating archives with the command git archive. Here's an example. Files and directories to exclude from archives. .git attributes export ignore, .git ignore export ignore, .github export ignore, test/export ignore, doc/export ignore, star_test.js export ignore, readme.md export ignore. This approach creates cleaner release archives without development-only files. It's useful when distributing your code as a library or plugin, and it keeps documentation and test files in the repository but out of releases. Let's delve into some advanced Git attributes. First, consider filter attributes. Use filters to modify content when files are checked in or out. For example, star.js filter equals indent. Secrets.json filter equals git-crypt. Remember that this requires configuring filter drivers in Git config. Next, let's explore merge strategies. Control how Git handles merges for specific files. For example, changelog.md merge equals union. Star.db merge equals binary. Star.properties merge equals properties. This helps prevent merge conflicts in files with specific formats. Here are some recommendations for the effective use of .git attributes files. First, commit early. Add .git attributes at the beginning of your project. Normalize line endings. Always use star_text equals auto as a baseline. Document your choices. Add comments explaining non-obvious attributes. Be specific. Use precise patterns to target the right files. Test your settings. Verify attributes work as expected across platforms. And finally, update when needed. Revise as your project evolves and file types change. A well-configured .git attributes file improves collaboration and prevents common Git issues. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. Git hooks are scripts that automate actions at different points in a Git workflow. They are essentially scripts that Git executes before or after events such as commit, push, and receive. Git hooks allow you to customize Git's internal behavior and trigger customizable actions at key points in the development lifecycle. Git hooks are divided into two main categories: client-side hooks and server-side hooks. Client-side hooks operate on your local machine. Examples of client-side hooks are pre-commit, prepare commit message, post-commit, and pre-push. Server-side hooks, on the other hand, run on the remote repository. Examples of server-side hooks include pre-receive, update, post-receive, and post-update. This diagram shows how different hooks interact with your Git workflow in both client and server sides. Git hooks are stored in the .git/hooks directory of every Git repository. Each hook is a separate script file named after the hook it implements. By default, hook files have a .sample extension and are inactive. To activate a hook, remove the .sample extension and make the file executable. To explore Git hooks, list all the hooks in a Git repository by running the command ls-li git/hooks. The sample output lists the default hooks with the .sample extension. To create a Git hook, first navigate to the .git/hooks directory in your repository. Then create a new file with the name of the hook you want to implement, for example, pre-commit. Next, write your script using Bash, Python, Ruby, or any other executable scripting language. After that, make the hook executable by using the command chmod+x. Finally, test your hook by triggering the corresponding Git action. Here is a sample pre-commit hook that checks for debugging code. Common client-side hooks include pre-commit, commit message, and pre-push. The pre-commit hook runs before a commit is created. If this hook exits with a non-zero status, the commit is aborted. Common use cases include linting code for style issues, running tests on changed files, and checking for debugging code. The commit message hook runs after the commit message is created, but before the commit is finalized. It can be used to validate or modify the message. Common use cases include enforcing a commit message format, adding issue or ticket references, and preventing commits with empty messages. The pre-push hook runs before code is pushed to a remote repository and provides a last chance to prevent code from being shared. Common use cases for pre-push hooks include running a full test suite, preventing pushing to protected branches, and checking for sensitive data. Server-side Git hooks run on the remote repository when receiving pushed commits. They can enforce project policies and perform automated actions. Common server-side hooks include pre-receive, update, and post-receive. The pre-receive hook runs when the server receives a push, before any references are updated, and can reject pushes based on their content. The update hook is similar to pre-receive, but it runs once for each branch being updated, and can reject updates to specific branches. The post-receive hook runs after all references have been updated, and is ideal for notifications and triggering continuous integration and continuous delivery pipelines. Common use cases for server-side hooks include enforcing branch policies, triggering continuous integration and continuous delivery pipelines, and sending notifications. Let us consider a practical example: enforcing a commit message format. This commit message hook enforces a conventional commit format, which is type, scope description, where type must be one of feat, fix, docs, style, ref actor, test, or chore. This helps maintain a clean, searchable commit history and can be used to automate versioning and changelog generation. This is a sample commit message hook implementation. The challenge of sharing Git hooks with your team is that Git hooks are stored in the .git/hooks directory, which is not included in the repository and cannot be directly shared with other team members. There are several solutions to this problem. The first is to create a custom hooks directory. Configure Git to use hooks from a directory that is tracked in your repository. The second solution is to use Git hook management tools like Husky, Precommit, or Lefthook to manage and share hooks. The third solution is to create setup scripts that install hooks when developers clone the repository. This is how to use a custom hooks directory. Husky is a popular tool that makes Git hooks easy to manage and share across a team. It integrates with your package.json and automatically sets up hooks when developers install dependencies. Benefits of using Husky are: it is easy to set up and configure, hooks are version controlled, installation is automatic for all team members, it works well with NPM or Yarn scripts, and it supports all Git hooks. To install Husky as a dev dependency by running the command npm install husky, save dev. Enable Git hooks by running the command npx husky install. Then, add hook installation to package.json by running the command npm setscript prepare followed by husky install. To configure hooks with Husky, add a precommit hook that runs lint by running the command npx husky add husky/precommit followed by npm run lint. Add a commit message hook for the message format with the command npx husky add husky/commit message followed by npx space hyphen no space hyphen commit lint hyphen edit $1. Some best practices for Git hooks include keeping the hooks fast. Especially precommit hooks should run quickly to avoid disrupting the workflow. Also, make the hooks skippable and provide a way to bypass hooks in emergency situations with no verify. Document your hooks and make sure team members understand what hooks do and why they are important. Use tools like Husky to simplify hook management and sharing across the team. Common pitfalls to avoid include overly strict hooks. Hooks that are too restrictive can frustrate developers and slow down work. Avoid slow performance, as running full test suites in precommit hooks can make the commit process painfully slow. Avoid a lack of documentation. Hooks that fail without clear error messages lead to confusion. Also, avoid platform dependencies, as hooks that only work on certain operating systems create inconsistency. Some further resources for learning about Git hooks are the official Git documentation, Husky, and the Precommit framework. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Precommit hooks, running checks before committing changes. In software development, ensuring code quality and consistency is crucial. One effective way to achieve this is by using precommit hooks. These hooks are automated checks that run before you commit your code, helping you catch issues early and maintain a high standard of code quality. What are precommit hooks? Precommit hooks are scripts that run automatically before a commit is completed in Git. They allow you to inspect the changes that are about to be committed and can prevent the commit if certain conditions aren't met. The purpose of precommit hooks are to catch issues early in development, enforce code quality standards, prevent problematic code from entering the repository, automate repetitive checks, and maintain consistency across team members. How do precommit hooks work? First, a developer adds files to the staging area with the command git add. Then a developer runs git commit to save changes, initiating the commit process. Precommit hooks then run automatically to check the code. Finally, the commit proceeds or is blocked based on the hook results. This ensures that only code that meets the defined standards is committed to the repository. Here are some common use cases for precommit hooks. Code linting enforces coding style and catches syntax errors using tools like ESLint, PyLint, or Rubocop. Unit testing runs tests to ensure code changes don't break existing functionality. Code formatting automatically formats code using tools like Prettier, Black, or Goft. Security scanning checks for security vulnerabilities, secrets, or credentials in code. Code complexity analyzes and limits code complexity to maintain maintainability. Finally, precommit hooks can prevent commits to protected branches or with specific patterns, like to-do comments. Let's discuss setting up pre-commit hooks. For manual setup, first create a .git/hooks directory in your repository. Next, create a file named precommit with no extension. Then, make the file executable with the command chmod +x. Write your script using Bash, Python, or any executable language. Finally, test your hook by making a commit. Here's a basic pre-commit hook example. The script starts with a shebang line, specifying that it should be executed with Bash. It then echoes, which means prints running pre-commit hook. The script checks for console.log statements in JavaScript files, uses git diff to find changed JavaScript files, and then uses grep to search for console.log statements. If console.log is found, it prints an error message and exits with code 1, which indicates failure. Otherwise, it exits with code 0 indicating success. An easier way to set up pre-commit hooks is by using the pre-commit framework. The pre-commit framework is a Python package that simplifies managing and maintaining pre-commit hooks. It provides a collection of ready-to-use hooks and makes it easy to share hooks across projects. To use it, first, install pre-commit using the command pip install pre-commit. Next, create a file named .precommitconfig.yaml. Then, install hooks by running the command precommit install. Finally, commit changes as usual. Here's a sample configuration file. Under repos, it specifies 3 repositories: precommit/precommit hooks, psf/black, and pika/flake8. For each repository, it defines a set of hooks to run, such as trailing whitespace, end of file fixer, check-YAML, black, and flake8. Let's see how to create custom pre-commit hooks. When built-in hooks don't meet your needs, you can create custom hooks tailored to your project requirements. First, scripts should be executable and have a shebang line. Next, return exit code 0 for success, non-zero for failure. Keep hooks focused on a single responsibility. Include clear error messages for failures. Test hooks thoroughly before deployment. And finally, document hook behavior for team members. Here's how to use a custom hook in the pre-commit framework. Here, a local repository is defined, and a hook named forbidden words is set up to check for forbidden words like to-do or fixm. The hook is implemented in the file check_forbidden_words py, uses Python and applies to text files, excluding files in the .git directory. This configuration ensures that the custom hook runs during the commit stage. Here are some best practices for pre-commit hooks. Keep hooks fast, so optimize hooks for speed to avoid disrupting workflow. Run comprehensive tests in continuous integration and continuous delivery pipelines instead of pre-commit hooks. Use version control for your hooks, storing hook configurations in version control to ensure consistency across all team members and environments. Focus on specific issues. Design hooks to catch specific problems rather than trying to solve everything. Each hook should have a clear single responsibility. Finally, provide bypass options. Allow developers to bypass hooks in exceptional cases using the command git commit --no-verify, but log these exceptions. In summary, pre-commit hooks automate code quality checks before changes are committed. They help catch issues early in the development process. They can be set up manually or using frameworks like pre-commit. Pre-commit hooks enforce consistent standards across team members. For further resources, you can visit precommit.com, gitscm.com/docs/githooks, and github.com/precommit/precommithooks. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. In this video, we're diving into Git submodules, a powerful feature that lets you include other Git repositories within your project. We'll explore how submodules can help you manage external dependencies, shared components, and maintain a modular project structure with independent versioning. Git submodules allow you to include other Git repositories within your repository. They are particularly useful for incorporating third-party libraries or shared components into your project. Each submodule maintains its own identity and history, which enables a modular project structure with independent versioning. This is different from simply copying code into your project because the submodule retains its link to its original repository. To add a Git repository as a submodule, use the command git submodule add, followed by the URL of the repository and the path where you want to place it within your project. For example, git submodule add https://github.com/username/library gitlib/library. This command performs several actions. First, it creates a new .gitmodules file containing the submodule configuration. Second, it clones the specified repository to the specified path. Third, it adds the submodule to the staging area. The .gitmodules file stores the configuration information for your submodules. It includes the path and the URL of the submodule repository. This file is committed to your repository and shared with everyone who clones your project, ensuring that everyone knows which submodules to use. When cloning a repository that contains submodules, you need to ensure that the submodules are properly initialized and updated. The easiest way to do this is by using the command git clone recurse submodules, followed by the repository URL. This command clones the main repository and automatically initializes and updates all of its submodules. If you have already cloned the repository without using the recurse submodules option, you can initialize and update the submodules separately. First, run git submodule init to initialize the submodules. Then, run git submodule update to fetch the submodule content. You can also combine these two steps into a single command by using git submodule update init. To check the status of your submodules, use the command git submodule status. The output will show the commit ID of each submodule along with the path. A plus sign indicates that the submodule commit has changed and needs to be updated. To update all submodules to the latest commit, use the command git submodule update remote. If you want to update a specific submodule, specify its path after the remote option, such as git submodule update remote lib/library. The diagram here visually represents how the main repository and submodule evolve over time, illustrating the importance of keeping them synchronized. To make changes within a submodule, first navigate to the submodule directory using the cd command. Once inside the submodule, you can work as you normally would with a Git repository. Make changes, commit them, and push them to the submodule's remote repository. Keep in mind that changes made in submodules need to be committed separately from the main repository. After committing and pushing changes to the submodule, return to the main repository directory. To incorporate the changes from the submodule into the main repository, you need to add the updated submodule to the staging area and commit the changes. The main repository tracks which commit of the submodule it's using, so committing the submodule updates the pointer to the new commit. Here's a recommended workflow for working with Git submodules. Always pull changes with the recurse submodules option to keep your submodules in sync with the main repository. It's a good practice to work in branches, creating feature branches in both the main repository and the submodules to isolate your work. When committing changes, first commit the changes in the submodule, and then update the main repository to point to the new submodule commit. This ensures that the main repository always references a valid state of the submodule. Use git pull recurse submodules to pull changes and update submodules simultaneously. Also use git push recurse submodules equals check to ensure that all submodule changes are pushed before pushing the main repository changes. To remove a submodule, use the command git submodule dainit, followed by the submodule path, then use git rm to remove the submodule from the repository. Commit these changes with a descriptive message. To change the URL of a submodule, use the git config command to update the submodule URL property in the .gitmodules file. After changing the URL, run git submodule sync to synchronize the configuration. To use a specific commit or tag in a submodule, navigate to the submodule directory, check out the desired version using git checkout, and then return to the main repository and commit the changes. It's a common mistake to forget to commit submodule changes in the main repository, which can lead to detached head states for other team members. Always ensure that submodule changes are properly committed and pushed in the main repository. Git submodules offer precise version control of dependencies and keep your repository history clean and separate. They work with any Git repository and don't require additional tools, supporting exact commit pinning. However, there are alternatives. Git subtrees merge external code directly into your repository. Package managers like npm, pip, and composer handle language-specific dependencies. Monorepos consolidate multiple projects into a single repository, and Git Large File Storage, or LFS, is designed for managing large binary files. The choice between submodules and these alternatives depends on your project's specific needs and your team's preferred workflow. Here are some best practices for working with Git submodules. Always reference specific commits or tags in submodules to ensure consistency across all environments. Regularly update submodules and communicate changes to team members to prevent conflicts. Include clear instructions in your README about how to clone and work with submodules in your project. Always check submodule changes with git diff submodule before committing to the main repository. In summary, Git submodules provide a powerful way to include external repositories in your project while maintaining separate version histories. When used correctly, they enable modular development and precise dependency management. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. This video is about Git subtrees, an alternative approach to manage project dependencies. Let us learn about it. Git subtrees are a Git feature that lets you include code from another repository. It embeds the external code directly into your main repository. No special commands are needed to clone the repository. The history of the subtree is preserved. As diagram shows, the external repositories subtree A and subtree B are embedded inside the main repository. Now let us see the difference between Git subtrees and Git submodules. With subtrees, the code is fully integrated into the main repository. No special commands are needed to clone the repository. History is preserved within the main repository. It is easier for team members who do not need to modify the dependency. Changes to the subtree can be committed directly. On the other hand, with submodules, there are references to external repositories. It requires special commands to initialize and update. It keeps repositories completely separate. It is better for dependencies that change frequently. It involves a more complex workflow for team members. When should you use Git subtrees? Good use cases are when you want to include third-party code that changes infrequently, when all team members need the dependency code, when you want to modify the dependency code within your project, when you want to simplify the repository for other developers. On the other hand, it is not ideal for dependencies that change frequently with upstream updates, when you need to keep the dependency completely separate, very large dependencies that would bloat your repository, when you need fine-grained control over which version of the dependency each developer uses. Here are some basic Git subtree commands. To add a subtree, use the command git subtree add, followed by prefix equals path /to/ folder, then remote URL branch, and finally, squash. For example, git subtree add, prefix equals vendor/library, https://github.com/user/library, git main, squash. To update a subtree, use the command git subtree pull followed by prefix equals path /to/ folder, then remote URL branch, and finally, squash. For example, git subtree pull, prefix equals vendor/library, https://github.com/user/library, git main, squash. To push changes back, use the command git subtree push followed by prefix equals path /to/ folder, then remote URL branch. For example, git subtree push, prefix equals vendor/library, https://github.com/user/library, git main. Here is a step-by-step process to add a subtree to your project. First, identify the external repository you want to include. Decide where in your project structure to place the subtree. Add the external repository as a remote. This step is optional but recommended. Use the git subtree add command with the prefix option. Use squash to condense the history. This is also recommended. Here are some example commands. To add the external repository as a remote, use the command git remote add library remote, https://github.com/user/library, git single quote. To add the subtree, use the command git subtree add, prefix equals vendor/library, library remote main, squash. After this command, you will see the output added dir vendor/library. To verify the subtree was added, use the command git log -1 -1. After this command, you will see the output a 1b2c3d merge commit as vendor/library. Here is the update workflow for a subtree. First, check for updates by fetching the latest changes from the external repository. Second, pull changes by using git subtree pull to update your subtree with the latest changes. Third, resolve conflicts. If there are conflicts between your changes and upstream changes, resolve them. Fourth, commit and push. Commit the merged changes and push to your repository. Here are some example commands. To fetch the latest changes, use the command git fetch library remote. To pull the latest changes into your subtree, use the command git subtree pull, prefix equals vendor/library, library remote main, squash. After this command, you will see the output from https://github.com/user/library, the branch name main, and then the merge details. If you have conflicts, resolve them and commit. Use the command git add vendor/library. Then use the command git commit and resolve conflicts in library subtree. To contribute changes back to the original repository, follow these steps. Make changes to the subtree files in your main repository. Commit the changes to your main repository. Use git subtree push to send changes back to the original repository. Create a pull request if you don't have direct write access. Important note: you need appropriate permissions to push directly to the original repository. Otherwise, consider forking the repository first. Here are some example commands. Make changes to files in the subtree. First, change directory to vendor/library. Then edit files. Commit changes to your main repository. Use the command git add vendor/library. Then use the command git commit and update library with new feature. Push changes back to the original repository. Use the command git subtree push, prefix equals vendor/library, library remote main. Here are some best practices for Git subtrees. Always use the squash flag when adding or updating subtrees to avoid cluttering your history with all the commits from the external repository. Document your subtrees by keeping a record of all subtrees in your project, including their source repositories, paths, and the commands used to add and update them. Create aliases. Set up Git aliases for common subtree commands to simplify your workflow and reduce typing errors with these complex commands. Avoid modifying subtrees when possible. Avoid making changes to subtree code. If you need to customize the dependency, consider forking it first or using patches. Git subtrees provide a powerful way to manage dependencies while keeping your repository self-contained and easy to work with. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. Welcome to the world of Git Large File Storage, or LFS. In this presentation, we'll explore how to effectively manage large files within Git repositories. Git LFS is an essential tool for developers, designers, and data scientists working with big files. It ensures version control without the bloat. Storing large files outside your Git repository leads to faster cloning and fetching, and provides a seamless version control workflow. Let's understand the problems associated with large files in Git. Git is not inherently designed to handle large files efficiently. When we add big files directly into a Git repository, several issues arise. First, the clone and fetch operations become very slow, making it difficult for team members to quickly get the latest version of the project. Second, the repository size balloons, consuming unnecessary storage space. Third, Git storage of binary files is inefficient, as it saves every version of the file, increasing the repository's size exponentially. Finally, bandwidth limitations become a pain point, especially when team members are in different geographic locations. Git stores the complete history of every file, which makes the repository heavy. In the illustration, you can see that files like video.mp4, dataset.csv, and images.zip makes the repository large. So, what exactly is Git LFS? Git Large File Storage, or LFS, is a Git extension designed to handle large files efficiently. Instead of storing the actual file content in Git, LFS replaces those large files with text pointers. These pointers are stored in Git, while the actual file contents are stored on a remote server. Now let's see the key points of Git LFS. It was developed by GitHub in 2015. It is an open source extension, and it is supported by major Git hosting services. Now let's dive into how Git LFS actually works. The first step is to install the Git LFS extension and initialize it in your repository using the commands git lfs install and git lfs install local. The second step is to specify which file type should be managed by Git LFS with the command git lfs track with the extension of the file. The third step is to add, commit, and push files as usual. Git LFS handles the large files automatically. To add the Git attributes file, use the command git add at git attributes, and to add and commit files, use the command git add file.psd, and git commit with a commit message, and then git push to the remote repository. Behind the scenes, Git LFS replaces large files with text pointers and uploads the actual content to the LFS server. Let's install Git LFS. For Windows and Mac OS, you can download the Git LFS installer from the official website at git-lfs.github.com. Run the installer and follow the instructions. To verify that Git LFS has installed correctly, use the command git lfs version. On Mac OS, you can also install Git LFS using Homebrew with the command brew install git-lfs. For Linux systems, use the package manager specific to your distribution. On Debian or Ubuntu, use the command sudo apt get install git-lfs. On Fedora, use the command sudo dnf install git-lfs. After installing, you should initialize Git LFS with the command git lfs install. For other distributions, you can download and install from the source from the releases page on the Git LFS GitHub repository. Now let's learn about basic Git LFS commands. The first command is git lfs track, which is used to specify which files or file patterns should be managed by Git LFS. For example, to track all Photoshop files, we can use the command git lfs track ***.psd*. To track all files in a directory, we can use the command git lfs track *videos /***. Don't forget to commit the .git attributes file to save the tracking patterns. The second command is git lfs track, which is used to view all file patterns currently being tracked by git lfs. The output will be like the listing of tracked patterns with the file and .git attributes. These patterns are stored in the .git attributes file. The third command is git lfs status, which is used to view the status of git lfs files in your repository. The command git lfs status shows LFS files that would be uploaded. The command git lfs status double-json gives a detailed status with file sizes. It helps identify which files will be managed by LFS before pushing. The fourth command is git lfs ls-files, which is used to view all LFS files in your repository. The command git lfs ls-files lists all LFS files. The command git lfs ls-files-s lists files with size and status. This command shows which files are currently being managed by git lfs. Now let's learn about advanced git lfs commands. The first command is git lfs fetch. It downloads LFS content for specific files. Use the command git lfs fetch to fetch LFS content, and use the command git lfs fetch double-include =PSD to fetch for specific files. This is useful when working with partial clones or specific files. The second command is git lfs prune. This command removes cached LFS files from local storage. Use the command git lfs prune to remove old LFS files, and use the command git lfs prune double-dry-run double-verbose to verify what would be pruned. This helps to reclaim disk space by removing unused LFS objects. The third command is git lfs migrate. This command converts existing files in repository history to use LFS. Use the command git lfs migrate import double-include =PSD to import files to LFS, and use the command git lfs migrate import double-include =zip double-fixup to modify recent commits. Note that it requires git-lfs-migrate extension. Use with caution on shared repositories. The fourth command is git lfs untrack. This command stops tracking specific files with git lfs. Use the command git lfs untrack *PSD to stop tracking a pattern, and use the command git lfs track to check if a pattern is untracked. This removes the pattern from .git attributes but doesn't affect already committed files. Here are some git lfs best practices. First, track the right files, which means to be selective about which files to track with git lfs. Track binary files that change frequently, large media files like images, videos and audio, and dataset files and archives. Avoid tracking small text files or code. Second, maintain the .git attributes file by keeping your .git attributes file organized and committed. Always commit .git attributes first. Group related file patterns together. Add comments for clarity. Third, follow workflow integration to integrate git lfs smoothly into your development workflow. Install git lfs on all team members' machines, include LFS setup and onboarding documentation. Use CI/CD systems that support git lfs. Consider partial clones for very large repositories. And fourth, watch out for storage quotas on hosting services, bandwidth limitations for large pushes and pulls, forgetting to track new binary file types, not running "git lfs install" in new clones, and migrating existing repositories incorrectly. Let's explore some real-world use cases for git lfs. The first use case is game development. Game projects contain numerous large assets that change frequently during development. Git lfs helps manage these assets efficiently, while keeping the repository size manageable. Some of the file types are 3D models, textures, audio, and Unity assets. The second use case is design projects. Design teams work with large source files that need version control. Git lfs allows designers to collaborate on projects without bloating the repository. Some of the file types are Photoshop files, Illustrator files, sketch files, and high-resolution images. The third use case is data science. Data scientists need to track datasets and model files alongside code. Git LFS provides a way to version these large files without compromising repository performance. Some of the file types are datasets, model files, Jupyter notebooks, and visualizations. The fourth use case is mobile app development. Mobile apps often include assets like images, videos, and compiled libraries. Git LFS helps manage these resources while keeping the code base lightweight. Some of the file types are app icons, marketing assets, video tutorials, and binary libraries. Let's summarize what we have learned so far. Git LFS solves the problem of storing and versioning large files in Git repositories. It replaces large files with text pointers while storing actual content on a remote server. It improves repository performance with faster clones and reduced storage requirements. It is simple to set up and integrates seamlessly with existing Git workflows. It is essential for projects with large binary files, media assets, or datasets. Thank you. Here are some Git LFS resources: official documentation, GitHub repository, Atlassian Git LFS tutorial, Git LFS on GitHub Docs, and Git LFS environment variables. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. Welcome to this introductory guide on Git worktrees. In this video, we'll explore how Git worktrees can help you work on multiple branches simultaneously. We will explain all the concepts from scratch so you can follow along even if you are new to Git. So, what exactly are Git worktrees? Git worktrees allow you to check out multiple branches from the same repository into different directories. Each worktree has its own working directory, which means you can work on several branches at the same time, without them interfering with each other. What are the benefits of using worktrees? Firstly, you no longer need to stash changes when you want to switch between different tasks. Secondly, you can work on multiple features or bug fixes in parallel, greatly improving your productivity. Thirdly, you can avoid the overhead of having multiple clones of the same repository, saving disk space and time. Let's compare the traditional Git workflow with the worktrees workflow. In a traditional workflow, suppose you're working on feature A, but you need to quickly fix a bug. What do? First, you have to stash your changes. Second, you switch to the bug fix branch. Third, you fix the bug and commit your changes. Fourth, you switch back to your feature branch. Finally, you pop the stash to continue your work. This process is quite cumbersome. Now let's see how worktrees simplify this. With worktrees, if you're working on feature A in its own worktree, and you need to fix a bug, there's no need to stash anything. First, simply navigate to the bug fix worktree directory. Second, fix the bug and commit. Finally, navigate back to your feature worktree, and you can continue working without any interruption. Worktrees streamline your workflow, making it more efficient and less error-prone. Here are some basic Git worktree commands you should know. First, to add a worktree, use the command git worktree add path to directory branch name. This creates a new worktree for the specified branch in the given directory. Second, to list all worktrees associated with your repository, use the command git worktree list. This will show you each worktree's path and the branch it's linked to. Third, to remove a worktree when you're done with it, use the command git worktree remove path to directory. Remember to commit or stash your changes in the worktree before removing it, or use the force flag, which we will discuss later. Let's see how to create a new worktree with a practical example. First, to create a worktree for an existing branch, use the command git worktree at /feature-login feature/login. This command creates a new directory named feature-login in the parent directory. It then checks out the feature/login branch in that directory. You can now work on this branch independently. Second, to create a worktree with a new branch, use the command git worktree add-b feature/navbar main. This creates a new branch called feature/navbar and bases it on main. It then sets up the worktree in the /navbar directory. Now let's explore how to manage your worktrees effectively. First, the git worktree list command shows the path to each worktree, the commit hash for the head, and the branch name in brackets. This gives you an overview of all your active worktrees. Second, to remove worktrees, use the command git worktree remove/feature-login. This removes the worktree directory and its administrative files. If you have uncommitted changes, you can force the removal using the command git worktree remove-force/navbar. Keep in mind that removing a worktree does not delete the branch itself, only the worktree. Let's dive into some advanced worktree usage. First, you can lock a worktree to prevent it from being accidentally deleted or moved. To lock a worktree, use the command git worktree lock/feature-login-reason =WIP. Don't touch. To unlock it, use git worktree unlock/feature-login. Locking is useful when you have work in progress that you don't want disturbed. Second, you can create detached head worktrees, which are worktrees at specific commits or tags. For example, git worktree add/old-version 78 of 53D creates a worktree at the specified commit. Similarly, git worktree add/v2.0 v2.0 creates a worktree for the v2.0 tag. This is useful for examining code at a specific point in history, testing older versions, or creating hotfixes for released versions. Let's walk through a practical workflow example. Imagine you're developing a feature while also needing to handle production issues. First, set up your main repository by cloning it and navigating into the directory. Second, create a feature worktree using the command git worktree add-b feature/auth main. Third, navigate to the feature worktree and start development. Now, suppose a production bug is reported. Fourth, create a hotfix worktree from the production branch using the command git worktree add-b hotfix/login/hotfix production. Fifth, navigate to the hotfix worktree, fix the bug, and commit the changes. Sixth, return to your feature work by simply navigating back to your feature worktree and continue where you left off. Let's recap some best practices and summarize what we've learned. Use a consistent naming convention for your worktree directories. Keep worktrees in a parent or sibling directory to your main repository. Always clean up worktrees when you're done with them. Use locks for worktrees with important uncommitted changes. Consider using integrated development environment workspace features to manage multiple worktrees. And remember that Git hooks apply to all worktrees. To summarize, Git worktrees boost productivity by eliminating context switching overhead. They enable parallel development, allowing you to work on multiple tasks simultaneously. They promote resource efficiency by sharing Git objects, saving disk space. They're ideal for code reviews, hotfixes, and maintaining multiple project versions. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Welcome to this video on Git Cherry Pick. Today we are going to explore how to apply specific commits from one branch to another in Git. Let's dive in. So, what exactly is Git Cherry Pick? Git Cherry Pick is a powerful command that allows you to select specific commits from one branch and apply them to another. Think of it like picking cherries from one tree and placing them onto another. You are handpicking certain changes and applying them where they are needed. Now let's explore some common scenarios where Git Cherry Pick comes in handy. First, hotfix backporting. You can apply a bug fix from the development branch to a stable release branch without merging all the changes. Second, selective feature transfer. Move specific features from one branch to another without including unrelated changes. Third, experimental changes. Test specific commits in isolation before integrating them into the main codebase. Finally, recovering lost work. Retrieve specific commits from abandoned or deleted branches that contain valuable work. Let's take a look at the basic syntax for using git cherry pick. The most common use is to cherry pick a single commit. Git cherry pick commit hash. To cherry pick multiple commits, simply list their hashes. Git cherry pick commit hash 1 commit hash 2. You can also cherry pick a range of commits using git cherry pick start commit, end commit. Before cherry picking, make sure you are on the target branch, ensure your working directory is clean, and identify the commit hash you want to cherry pick. Remember, cherry picking creates a new commit with a new hash, even if the changes are identical to the original commit. Let's walk through a simple cherry pick operation step by step. Step 1. Find the commit to cherry pick using the command git log, one line. This will show you a list of commits with their short hashes and commit messages. Step 2. Switch to the target branch where you want to apply the commit using the command git checkout release. Replace release with the name of your target branch. Step 3. Cherry pick the commit using the command git cherry pick e4f5g6h. Replace e4f5g6h with the commit hash you want to cherry pick. After this, Git will apply the changes from the specified commit to your current branch, and it will create a new commit with those changes. Git cherry pick comes with several advanced options that can be very useful. The no commit option. Apply changes without creating a commit. Useful when you want to combine multiple cherry picks into a single commit. The edit option. Modify the commit message during cherry pick operation. Handling conflicts. When conflicts occur, you can continue after resolving them or abort the operation. The sign off option. Add a signed off by line to the commit message, certifying you have the right to submit the code. Let's discuss how to handle conflicts during a cherry pick. First, when conflicts occur, Git will pause the cherry pick operation and mark the conflicting files. You'll need to resolve these conflicts manually by editing the files. Second, after resolving conflicts, once you've resolved all conflicts, add the files using the command git add. And continue the cherry pick process using the command git cherry pick. Continue. Finally, aborting cherry pick. If you decide not to proceed with the cherry pick, you can abort the operation and return to the previous state using the command git cherry pick. Abort. Here are some best practices to keep in mind when using cherry pick. Use atomic commits. Cherry picking works best with small focus commits that address a single concern. This minimizes the chance of conflicts. Document cherry picks. Add a reference to the original commit in your commit message to maintain traceability between branches. Be cautious with dependencies. Ensure you cherry pick all dependent commits to avoid breaking functionality. Consider using ranges when needed. Consider alternatives. For complex changes, merging or rebusing might be more appropriate than cherry picking multiple commits. Let's summarize what we've learned about Git cherry pick. Cherry pick allows you to apply specific commits from one branch to another. It's useful for hotfixes, selective feature transfers, and recovering lost work. Advanced options help manage conflicts and customize the process. It's best used with atomic commits and proper documentation. For further learning, you can refer to the official Git documentation and Atlassian Git tutorial. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. Git tags are references that point to specific points in Git history. They are used to mark release points and important milestones in a project's development. Think of them as permanent pointers to specific commits. Git tags are commonly used for version releases such as version 1.0.0 or version 2.1.5. There are two main types of tags: lightweight and annotated. These tags can be shared with remote repositories, allowing others to access specific release points. There are two primary types of Git tags: lightweight tags and annotated tags. Lightweight tags are simple pointers to specific commits. They store only the commit checksum without any additional information. To create a lightweight tag, you can use the command git tag v1.0.0-light. To list the available tags, use the command git tag. This will display a list of all available tags, including the newly created lightweight tag. Annotated tags, on the other hand, are full objects in the Git database. They contain additional metadata such as the tagger's name, email, date, and a tagging message. To create an annotated tag, use the command git tag -av1.0.0-m, release version 1.0.0. To view the details of an annotated tag, use the command git show v1.0.0. This will display the tagger information, date, and the release message. Git tags can be created for the current commit or for a specific commit in history. By convention, tags often follow semantic versioning, which consists of major, minor, and patch numbers. To tag the current commit with a lightweight tag, use the command git tag v1.0.0. For an annotated tag, which is the recommended approach, use the command git tag -av1.0.0-m, release version 1.0.0. You can also tag a specific commit using its commit hash. For a lightweight tag on a specific commit, use the command git tag v0.9.0, a 1b2c3d. For an annotated tag on a specific commit, use the command git tag -av0.9.0-m, beta release, a 1b2c3d. Remember, it is best practice to use annotated tags for releases, as they contain valuable metadata like the tagger's name, date, and message. To list all the tags in your repository, you can use the command git tag. This will display a list of all available tags such as v0.9.0, v1.0.0, and v1.1.0. You can also filter the tags by using a pattern. For example, to list all tags starting with v1, you can use the command git tag -l v1.star. This will display the tags that match the specified pattern, such as v1.0.0 and v1.1.0. To view the details of a specific tag, you can use the command git show v1.0.0. This will display the tag details, including the tagger information, date, release message, and the associated commit details. By default, the git push command does not automatically transfer tags to remote servers. To share tags, you need to explicitly push them. To push a specific tag, you can use the command git push origin v1.0.0. This will push the tag v1.0.0 to the remote repository. To push all tags at once, you can use the command git push origin -tags. This will push all the tags to the remote repository. Alternatively, to push all annotated tags, you can use the command git push origin -follow -tags. To fetch remote tags, you can use the command git fetch -tags. Many Git hosting platforms such as GitHub, GitLab, and Bitbucket use tags to mark official releases and can automatically generate release notes based on these tags. Sometimes it may be necessary to delete tags, especially if they were created by mistake or need to be replaced with corrected versions. To delete a local tag, you can use the command git tag -dv1.0.0. To delete multiple local tags at once, you can use the command git tag -dv1.0.0v1.1.0. To delete a remote tag, you can use either of the following methods. The first method is git push origin -delete v1.0.0. The second method is git push origin :refs/tags /v1.0.0. It is important to exercise caution when deleting tags that have been pushed and used by others, as this can cause confusion. you can check out a tag to view the state of your repository at that tag point in time. However, doing so puts your repository in a detached head state. To check out a tag, use the command git checkout v1.0.0. This command will check out the specified tag and display a message indicating that you are in a detached head state. When you are in a detached head state, you are not on a branch. Any commits you make will not be part of any branch and may be lost when you check out another branch. If you want to make changes based on a tag, it is recommended to create a new branch from the tag. To do this, use the command git checkout -b hotfix /1.0.1v1.0.0. This command will create a new branch named hotfix /1.0.1 from the tag v1.0.0 and switch to the new branch. When working with Git tags, there are several best practices to follow. First, use semantic versioning to clearly communicate the nature of changes in your releases. The versioning scheme is structured as major, minor, and patch, such as v1.2.3. Second, use annotated tags for releases, as they contain valuable metadata, like the tagger's name, date, and message that provide context. You can create an annotated tag using the command git tag -av1.0.0-m, release version 1.0.0. Tag on stable branches like main or master, or dedicated release branches, and not on feature branches. Finally, tag after CI/CD verification to ensure that the code passes all tests before creating a release tag. Remember that tags are immutable references, so once shared, avoid changing or deleting them. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. In this video, we're going to explore semantic versioning and how to effectively use it with Git for your software projects. Semantic versioning provides a structured way to number your software releases, making it easier to track changes and manage dependencies. Here's an example of a version number, 1.3. Let's break down what semantic versioning really means. A semantic version number typically follows the format x.y.z. The X represents the major version. This is increment when you make incompatible API changes. The Y represents the minor version, which you increment when you add functionality in a backwards compatible manner. The Z represents the patch version, which is increment when you make bug fixes that are also backwards compatible. To better understand semantic versioning, let's look at some examples. First, let's look at when to increment the major version. If your current version is 1.3.5, and you introduce incompatible API changes, you would increment the major version to 2.0.0. This also applies if there are breaking changes to the public API, removal of deprecated features, or major architectural changes. Next, let's consider when to increment the minor version. Again, if you're at version 1.3.5, and you add new features that are backwards compatible, you'll increment the minor version to 1.4.0. This also covers cases where functionality is deprecated, where substantial new functionality has been added, or there are new non-breaking API endpoints. Now let's examine when to increment the patch version. If your current version is 1.3.5, and you make bug fixes that are backwards compatible, you increment the patch version to 1.3.6. This also includes performance improvements, changes to private code, and small tweaks and improvements. It's worth noting that pre-release versions can be indicated with labels like alpha, beta, or release candidate. For example, 1.0.0-alpha, 1.0.0-beta.1, or 1.0.0-release candidate 1. Additionally, you can include build metadata such as a date or git commit hash, for example, 1.0.0 plus 2013, 03, 13, 14, 47, 00, or 1.0.0 plus git.5114f85. Now let's see how to implement semantic versioning with Git. First, set up your project. Initialize your project with a package.json file by running the command npm init-y. Then, set the initial version in package.json. For example, version 0.1.0. Finally, initialize your Git repository using the command git init. One crucial aspect of semantic versioning with Git is creating version tags. You can create a lightweight tag using the command git tag, followed by the version number, for example v1.0.0. However, it's recommended to create an annotated tag. This is done using the command git tag-a, followed by the version number, -m, and a descriptive message, for example release version 1.0.0. To share these tags with your team, you need to push them to the remote repository. You can push a specific tag using git push origin, followed by the tag name, for example v1.0.0, or you can push all tags using git push -- tags. To streamline your version management, it's helpful to establish an automated workflow. Start by updating the version in the package.json file. You can use the npm version command, followed by patch, minor, or major, depending on the type of changes you've made. Next, commit the version change. This involves using the commands git add package.json and then git commit -m, with a message indicating the version bump, for example, bump version to 1.2.0. Finally, create a tag and push the changes. This is achieved using the commands git tag-a, followed by the version number and a message, and git push -- tags. There are several tools available to assist with semantic versioning and automation. For automating versioning and changelog generation, consider using Standard Version. Install it using the command npm i-save-dev standard version. For standardizing commit messages, you can use Commitizn, which can be installed with npm i-save-dev Commitizn. For continuous integration and continuous deployment integration, Semantic Release provides fully automated version management and package publishing. It can be installed using npm i-save-dev Semantic Release. To enforce commit conventions, Husky can be used to implement Git hooks, installed with npm i-save-dev Husky. To wrap up, let's review some best practices for semantic versioning. First, use clear commit messages. Adopt the conventional commit format to clearly indicate the type of change, such as feature, fix, or docs. Also, maintain a changelog. Document all notable changes for each version in a changelog.md file. Automate when possible, using tools to automate version bumping, tag creation, and release notes. Finally, start at v0.1.0 for initial development and move to v1.0.0 for the first stable release. For additional resources, check out semver.org, conventionalcommits.org, and keepachangelog.com. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. Welcome to the world of Git Blame. Git Blame helps you find out who changed what and when in your code. It's like a detective tool for your Git repository. So, what exactly is Git Blame? Git Blame is a Git command that shows you which user last modified each line of a file, when they made the change, and the commit message associated with that change. The purpose of Git Blame is to help you understand the history and context of code changes. It helps identify who made specific changes and track down when bugs were introduced. Let's look at the basic usage of Git Blame. The basic syntax of the command allows you to see who modified each line of a file. The command is git blame followed by the file name. For example, git blame src/main.js. You can also blame a specific line range. For example, to blame lines 10 through 20, the command is git blame l10 20 src/main.js. Now let's understand the git blame output. Git blame output shows who last modified each line, when the modification was made, and the commit hash of that modification. Here's an example. The commit hash is A1B23D4. The author is John Doe. The date is 2023, May 10th, 14 hours, 30 minutes, 45 seconds, plus 0200. The line number is 1. The actual code is function calculate total items. Git blame comes with several useful options. You can examine only specific lines of a file using the L option, followed by the start and end line numbers, and then the file name. For example, git blame L1020 file name. To show blame for a specific revision of a file, use git blame followed by the revision number or tag, and then the file name. For example, git blame version 1.0 file name. To ignore whitespace changes when finding blame, use the W option. For example, git blame W file name. To show the author's email instead of their username, use the show email option. For example, git blame show email file name. Now let's discuss some advanced git blame options. You can detect moved or copied lines using the C and M options. C detects copies within a file, and CC is a more aggressive version. M detects moved lines. For example, git blame C file name, git blame CC file name, and git blame M file name. You can also ignore revisions using the ignore rev option followed by the commit hash, or use the ignore revs file option, followed by the path to a file containing a list of revisions to ignore. For example, git blame, ignore rev72a9bc file name, and git blame, ignore revs file.git blame ignore. Let's explore some practical examples of using git blame. When you discover a bug in a specific line of code, use git blame to find out who last modified that line, and when, helping you understand the context of the change. For example, to find who changed line 42 in app.js, the command is git blame L42, 42app.js. You can also combine git blame with other commands to get deeper insights into the history of a file or specific code section. For example, to show full commit details for a line, use the command git blame file.js L10, 10s print $1, zargs git show. Most modern integrated development environments, or IDEs, provide built-in git blame functionality with visual indicators. For example, in Visual Studio Code, you can use the Git Lens extension or the built-in git blame feature. In JetBrains IDEs, you can right-click, select Git, and then annotate. In Sublime Text, you can use the git blame package. And on GitHub, you can find the blame button in the file view. In summary, git blame helps identify who changed specific lines of code and when. It is useful for debugging, understanding code history, and finding context. Advanced options help track moved code and ignore formatting changes. IDE integration makes blame information easily accessible during development. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Git grep, powerful search capabilities for your codebase. Git grep is a command line tool that allows you to search through the contents of your Git repository. It's like the regular grep command, but specifically designed to work with Git repositories. Let's explore how you can use it to find what you're looking for quickly and easily. Git grep is a powerful search tool built into Git that allows you to search through your codebase efficiently. It allows developers to search for specific text or patterns within the files tracked by Git. Key features are: it can search through tracked files in your repository, you can filter results by file type, path, or commit, and it also uses regular expressions for advanced pattern matching. Importantly, it is faster than standard grep as it only searches tracked files. Let's start with some simple examples of how to use Git grep. To search for a string in all tracked files, you can use the command git grep, followed by the string you want to search for, enclosed in double quotes. For example, git grep, and then in quotes function. If you want to see the line numbers where the matches are found, you can add the n flag like git grep n, and then in quotes function. Now, let's explore some advanced options that can make your Git grep searches even more powerful. Firstly, context options. To show a few lines of context around each match, you can use the C flag followed by the number of lines you want to display. For example, git grep C3, and then in quotes function. This command shows 3 lines of context around each occurrence of function. Git grep isn't limited to just the current state of your files. You can also search through your Git history. Let's see how to do it. If you want to search for a specific commit, you can provide the commit hash after the search term. For example, git grep, and then in quotes function followed by a commit hash. This will search for the word function only within the specified commit. Git grep can be combined with other command line tools to perform more complex searches. Here are a couple of examples. To find files containing function but not test, you can use git grep l, and then in quotes function, pipe it to zargs grep l, and then in quotes test. This command first lists files containing function, and then filters out those that also contain test. To wrap up, here are some best practices to help you use git grep effectively. Use case-insensitive search with the I flag when appropriate. Combine with N for line numbers to quickly locate matches. Leverage regular expressions for complex pattern matching. And consider creating aliases for frequently used git grep commands. Now regarding when to use git grep versus other tools, use git grep for searching tracked files in your repository. Use standard grep or find for searching untracked files. Consider specialized code search tools for larger code bases. For further resources, you can refer to the Git documentation by typing git help grep in your terminal. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. Let's explore the power of the advanced git log command. In this tutorial, you'll learn how to filter and format your git log output to extract the exact information you need from your project's history. The most fundamental way to view the history of your repository is by using the git log command. When you execute this command in your terminal, Git displays a list of commits, starting with the most recent one. By default, each commit entry includes the commit hash, which is a unique identifier for the commit. The author's information, including their name and email address. The date and time when the commit was made, along with the time zone, and the commit message, which is a brief description of the changes made in that commit. Here's an example of how it will look like after running the command. The command is $git log. The output will have commit hash, author details, and the date along with the commit message. When dealing with repositories that have a long history, filtering the log output becomes essential. Let's see the different ways to limit the number of commits. To limit the number of commits displayed, you can use the N option followed by the desired number. For example, git log N3 will show only the 3 most recent commits. To view commits made within a specific time frame, you can use the since option. For example, git log since equals 2 weeks ago will show all commits made in the last 2 weeks. If you're interested in commits made by a particular author, you can use the author option followed by the author's name. For example, git log author equals John Doe will display only commits made by John Doe. To see commits that modified a specific file or directory, you can specify the path to the file or directory after the git log command. For example, git log path/to/file.js will show all commits that modified this file. Git log allows you to search for specific content within commit messages or code changes. You can search for commits that contain specific text in their commit messages. This is useful for finding commits related to a particular feature implementation or bug fix. To do this, use the grep option followed by the text you want to search for. For example, git log grep equals bug fix will show commits with the text bug fix in their commit messages. You can also search for commits that added or removed specific code. This is helpful for tracking when a particular piece of code was introduced or removed. Use the S option followed by the code you want to search for. For example, git log s function getUserData will show commits that added or removed this function. For more advanced searches, you can use regular expressions to find commits that match a specific pattern. Use the G option followed by the regular expression pattern. For example, git log guser will show commits with changes matching the provided regex. The pretty option in git log allows you to customize the output format of the log messages. There are several predefined formats available, such as one line, which displays each commit in a compact, single-line format, and short, which shows the author and abbreviated commit hash. Additionally, you can create custom formats using placeholders. The command $git log pretty equals one line will show output in single line. And $git log pretty equals format %h% and %ar. %s command will show short commit hash, author name, author date relative, and subject. When creating custom git log formats, you can use placeholders to specify which information to include in the output. Here are some commonly used placeholders and their descriptions. The %h placeholder represents the full commit hash. The %h placeholder represents the abbreviated commit hash. The %n placeholder represents the author name. The %ae placeholder represents the author email. The %at placeholder represents the author date. The %ar placeholder represents the author date, relative to the current time. The %s placeholder represents the subject or commit message. You can use these placeholders with the pretty equals format option to create custom log outputs. Git log provides options to visualize the commit history in a graphical format. The graph option displays the branch and merge history as an ASCII graph, making it easier to understand the relationships between branches. Combining graph with one line provides a compact visualization, showing each commit in a single line along with the graph. Adding all shows all branches in the graph, providing a comprehensive view of the repository's history. Additionally, using decorate shows branch and tag names, making it easier to identify important commits and branches. The sample command is $git log graph one line decorate. Git log offers options to view the changes introduced with each commit directly in the log output. The P or patch option shows the changes introduced with each commit in a patch format. This includes the additions, deletions, and modifications made to the files. The stat option displays statistics for files modified in each commit, such as the number of lines added or removed. The name-only option shows only the names of the files that were changed in each commit. The name status option shows both the names and the status of the changed files, indicating whether they were added, modified, deleted, or renamed. Sample command is $git log p-1. For more advanced filtering, Git log offers several options to narrow down the commit history based on specific criteria. To show commits that are present in one branch but not in another, you can use the git log main feature syntax. This will display commits that exist in the feature branch but not in the main branch. To exclude merge commits from the log output, you can use the No Merges option. This will show only direct commits, excluding any merge commits. To show only merge commits, you can use the Merges option. This is useful for tracking integration points in the repository's history. When dealing with merge commits, you can use the first parent option to follow only the first parent of each merge. This is useful for seeing the main branch history without including the details of feature branches. To simplify and streamline your Git workflow, you can save your favorite log formats as aliases in your Git configuration. This allows you to create shortcuts for complex commands, ensuring consistent formatting across projects, and making it easier to share with team members via .dot files. You can set the alias using the git config global alias.lg command. Now you can simply use git lg instead of the long command. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. Git shortlog is a powerful command line tool used to summarize the output of the git log command. It organizes commit history by author, making it easier to understand individual contributions and project summaries, and is particularly useful when creating release notes. The git shortlog command summarizes the output of git log, grouping commits by author, and displaying the first line of each commit message. To use it, simply type git shortlog in your terminal. This will output a list of authors, the number of commits they have made, and the first line of each of their commit messages. As an example, Alice Smith may have 3 commits related to user authentication, including adding the feature, fixing the login page styling, and updating the README. Similarly, Bob Johnson may have 2 commits focusing on implementing product search functionality and optimizing database queries. Git shortlog comes with several options that allow you to customize the output. The S or summary option shows only the commit count per author. This is useful for quickly seeing who has contributed the most. For example, the command git shortlog S would display a list of authors and the number of commits they have made, such as Alice Smith with 5 commits, Bob Johnson with 3, Carol Williams with 2, and David Brown with 1. The N or numbered option sorts the output by the number of commits instead of the author name. This will show the most active contributors first. For example, the command git shortlog sn will sort by the number of commits, displaying Alice Smith first with 5 commits, followed by Bob Johnson, Carol Williams, and David Brown. Here are a couple more useful options for git shortlog. The E or email option displays the email address of each author alongside their name. This can be helpful for identifying contributors more precisely. For example, git shortlog se would show Alice Smith, along with her email address, alice@example.com, and the number of commits. Another useful option is since or until. It filters commits by a date range, which is helpful for generating reports for specific periods. For example, git shortlog since 1 month ago would show commits made in the last month, listing authors like Alice Smith with her commits and Bob Johnson with his. Git shortlog offers advanced options to create custom reports. You can combine multiple options to create customized reports for your project. For example, git shortlog SNE since equals 2023-01-01 until equals 2023-12-31 would provide a summary, sort by number of commits, include email addresses, and filter commits between January 1, 2023 and December 31, 2023. This gives a detailed overview of contributions within that year. You can also filter by author. By combining with grep, you can filter commits by specific authors. For example, git shortlog sgrep Alice would show the commit count for Alice only, giving you a focused view of their contributions. Git shortlog has several practical applications. It can be used for generating release notes. You can create organized release notes by summarizing changes since the last release tag, grouped by contributor, using the command git shortlog v1.0.0, v2.0.0 releasenotes.txt. This command creates a text file with a summary of commits between version 1.0.0 and version 2.0.0, useful for documenting changes. Git shortlog is also useful for team contribution analysis. You can analyze team contributions over time to identify active contributors and workload distribution using the command git shortlog sn since equals 6 months ago. This command sorts the output by commit count and shows contributions made in the last 6 months, helping you understand who is actively contributing. Here are some tips and best practices for using git shortlog. First, use consistent author information. Configure your Git username and user email consistently across machines to ensure accurate attribution in short log reports. Second, create aliases for common reports. Set up Git aliases for frequently used short log commands to save time and ensure consistency. Third, combine with other Git commands. Pipe short log output to other commands like grep, sort, or head for more targeted analysis. Finally, export to files for documentation. Redirect short log output to text files for inclusion in project documentation or release notes. Git short log is a powerful tool for understanding project history and team contributions. Use it regularly to gain insights into your development process. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Welcome to Git History Visualization. In this presentation, we will explore how to use graphical tools to visualize your repository's history. Let's dive in. Why should you visualize your Git history? There are many benefits to doing so. Firstly, it helps you understand complex branching structures. Secondly, it lets you track your project's evolution over time. Thirdly, you can identify merge conflicts more easily. Fourthly, you can collaborate more effectively with teams. And finally, it helps to debug issues by tracing changes. Here are some popular Git visualization tools. First, we have GitKraken, a cross-platform Git client with an intuitive interface and powerful visualization features. It offers both free and paid versions, and it comes with features like interactive graph, cross-platform support, and a merge conflict tool. Next, we have SourceTree, a free Git client by Atlassian with a visual interface, simplifying Git operations and providing clear history visualization. It includes features like visual diff, Bitbucket integration, and Git flow support. Then there's Git Extensions, an open-source user interface tool for managing Git repositories, extending Visual Studio with Git functionality and standalone visualization. It features Visual Studio integration, is open source and is customizable. And finally, we have GitHub Desktop, a simplified Git client by GitHub focusing on essential workflows with clean visualization and GitHub integration. This includes GitHub integration, a simple interface, and pull request tools. Let's explore some command line visualization tools. One useful command is git log graph. This built-in Git command displays commit history as a text-based graph. The graph flag adds ASCII art to show the branching structure. Here is an example. Next, we have Gitforsta. This Perl script enhances Git's log output with improved ASCII visualization, providing better branch and merge visualization than the standard Git log. Here are more command line visualization tools. TIG is a text mode interface for Git that provides an interactive, Ncurses-based user interface for browsing Git repositories. It offers split views and keyboard navigation. Here's an example of its output. GitUp is a Git interface with a unique visualization approach. It features a live updating map view of your repository and quick actions for common operations. Let's examine some web-based visualization tools. GitGraph.js is a JavaScript library for creating customizable Git graph visualizations on web pages. It allows developers to build interactive Git history displays and includes features like JavaScript, customization, and interactivity. It can be found at gitgraphjs.com. Next up, we have GitHub Network Graph, a built-in visualization tool on GitHub that shows the network of commits and branches, providing a timeline view of repository activity. It includes GitHub integration, a timeline view, and requires no setup. This can be found at github.com/your-username/your-repository/network. Then we have Gorse, a software version control visualization tool that creates animated tree visualizations of Git repository history, showing files as nodes and developers as avatars. Features include animation, it's time-based, and has a developer focus. This can be found at gors.io. Finally, we have GitViz, a real-time visualization tool that shows Git operations as they happen, helping you understand Git's internal object model and how commands affect the repository. This tool is real-time, educational, and focuses on the object model. It can be found at github.com/readyfy/gitviz. Let's take a look at an example using GitKraken. In this slide, you can see a mock-up of the GitKraken interface. It visualizes branches using color-coded branches, which makes it easy to follow different lines of development. It has interactive commit nodes, which allows for easy exploration of changes. It provides visual merge indicators, which shows where branches have been merged together. Here are some best practices for Git history visualization. When it comes to branching strategies, the Git flow is a structured branching model with dedicated branches for features, releases, and hotfixes. GitHub Flow is a simpler approach with feature branches directly from main and regular deployments. And trunk-based development is where you have short-lived feature branches with frequent integration to main branch. Now let's examine visualization tips. It's recommended that you write meaningful commit messages that explain the why, not just the what. Make atomic commits, which makes each commit a logical unit of change to improve history readability. Use clean merges, use rebase or squash merges to maintain a cleaner, more linear history when appropriate. Let's summarize what we've covered and discuss some next steps. The key takeaways are that visualizing Git history improves understanding of project evolution and team collaboration. Also, there's a wide variety of tools available from command line to graphical user interface applications, each with its own unique strengths. Clean branching strategies and meaningful commits create more useful visualizations. If you're eager to learn more, here are some further learning resources, including the Pro Git book available at git-scm.com/book, Visualizing Git available at git-school, github.io/visualizing-git, and Learn Git Branching available at learngitbranching.js.org. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. In this video, we're going to explore Git aliases. Git aliases are a powerful feature that allow you to create shortcuts for frequently used Git commands. This can save you time, reduce typing errors, and help you customize your Git workflow. Git aliases are custom shortcuts for Git commands that you use frequently. They help you save time by reducing the amount of typing required for long commands, reduce typing errors, and help you create custom workflows. Let's look at an example. Without an alias, to create a new branch, you might type git checkout b feature branch. With an alias, you could simply type git cb feature branch. There are a couple of methods to create Git aliases. The first method involves using the git config command. To create an alias for Git status, you can use the command git config global alias.status. Similarly, to create an alias for Git checkout, you would use git config global alias.co-checkout. You can also create aliases with multiple commands. For example, git config global alias.ac, git add. And in git commit m, creates an alias that adds all changes and then commits with a message. To use this, you would type git ac followed by your commit message. Note that the exclamation mark allows running external commands. Another way to create Git aliases is by directly editing the git config file. This file is located at /.gitconfig on Linux or Mac, or c:\users\yourname/ gitconfig single quote on Windows. To open the config file with your default editor, use the command git config global edit. Alternatively, you can open it directly with a text editor like nano/.gitconfig or vim/.gitconfig. Inside the config file, you'll find a section labeled alias. Under this section, you can define your aliases. For example, st equals status, Co equals checkout, CB equals checkout B, CM equals commit M, BR equals branch, and unstitch equals reset head. After saving the file, your aliases will be immediately available for use. Here are some common Git aliases that can help streamline your workflow. ST for status helps you check the repository status. Co for checkout allows you to quickly switch branches. CB for checkout B enables you to create and switch to a new branch. CM for commit M lets you commit with a message. BR for branch is used to list branches. Unstitch for reset head removes files from the staging area. And last for log-1 head shows the last commit. Let's explore some advanced Git aliases for enhanced workflow. SE for git add. And in git commit M, adds all changes and commits them in one step. Amend for commit, amends the last commit. Undo for reset, soft head caret, undoes the last commit while keeping the changes. Visual for Git opens a visual Git history browser. LG for log graph, one line provides a pretty log with a graph. And aliases for config, Git rejects alias lists all configured aliases. Commands with an exclamation mark can execute shell commands and combine multiple Git operations. Here are some examples of custom Git aliases you can create. For pretty log visualization, use git config global alias.eld log graph pretty equals format %cred %h %crescit %z yellow %d %crescit %s %creen %r %c bold blue %and %crescit abbrev commit date equals relative. This will create a beautiful, readable log format with branches and commit info, and you can use it by typing git lg. For a quick commit workflow, use git config global alias.save git add a and in git commit m. This adds all changes and commits in one command, and you can use it by typing git save followed by your commit message. To find and remove all merged branches, use git config global alias.cleanup git branch merged grep *zargs git branch d. This alias cleans up your local repository by deleting all branches that have been merged into the current branch. You can use it by simply typing git cleanup. Here are some best practices to keep in mind when creating Git aliases. Keep aliases short but meaningful. Document your aliases for team sharing. Start with common aliases before creating custom ones. Use consistent naming conventions. Back up your .gitconfig file. And regularly review and update your aliases. In summary, Git aliases provide powerful shortcuts for frequently used commands, helping you increase productivity, reduce typing errors, customize Git to your workflow, and combine multiple commands into one. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Let's explore Git configuration levels. In this video, we will cover the understanding of system, global, and local configurations in Git. Each level plays a crucial role in how Git operates in different environments. Git uses a hierarchy of configuration files to determine settings. More specific configurations override general ones. It follows this order: local overrides global, which in turn overrides system. Each level serves different purposes, and values cascade down unless overridden. Here are some useful commands. To view all configurations and their source, use the command git config list show origin. To view the merged configuration, use the command git config list. To check a specific settings value, use the command git config user.name. Now let us discuss system-level configuration. System configuration is system-wide and applies to all users and all repositories on the computer. On a Linux or Mac OS system, it is typically found at /etc/gitconfig. On Windows, it is located at c:\program files /git /etc /git config. It is used for organization-wide or machine-wide settings. Keep in mind that it requires administrative privileges to modify. To set a system-level configuration, use the command git config system, followed by the configuration key and value. For example, to set the username, you would use the command git config system-user.name default user. To configure automatic carriage return and line feed conversion, use the command git config system_core.autocrf true. Next, we will learn about global level configuration. Global configuration is user-specific and applies to all repositories for the current user. It is stored in the user's home directory. On Linux or Mac OS, it is located at /.gitconfig. On Windows, it is located at c/users/username/.gitconfig. Common uses include personal identity settings, editor preferences, authentication credentials, and personal aliases. To set a global configuration, use the command git config global followed by the configuration key and value. For example, to set the username, you would use the command git config global user.name your name. Similarly, to set the user email, you would use the command git config global user.email@example.com. Now let's see local level configuration. Local configuration is repository specific and applies only to the current repository. It is stored in the repositories.git directory, specifically in the config file. Common uses include project-specific email addresses, repository-specific remotes, project-specific merge strategies, and overriding global settings for a project. To set a local configuration, navigate to your Git repository in the command line, and use the command git config, followed by the configuration key and value. For example, to set the project email, you would use the command git config user.emailproject@example.com. Similarly, to ignore case, you would use the command git config cord@ignore case false. Here are some common configuration commands. To view all configurations with their sources, use the command git config list show origin. To edit a specific configuration file, use the command git config global edit. To remove a configuration, use the command git config global unset user.email. To add a configuration, for example setting the core editor to Visual Studio Code, use the command git config local core.editor code wait. In summary, system configuration is for machine-wide settings for all users and repositories, and its path is /etc/gitconfig. Global configuration is for user-specific settings for all repositories, and its path is /.gitconfig. Local configuration is repository-specific settings that override others, and its path is .git/config. Here are some best practices. Use global configuration for personal identity and preferences. Use local configuration for project-specific settings. Check configuration sources when troubleshooting. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Let's understand SSH keys for Git and learn how to use secure password-free authentication for Git repositories. So, what exactly is SSH? SSH, which stands for Secure Shell, is a cryptographic network protocol. It provides a secure way to access and manage remote systems over an unsecured network. SSH uses public key cryptography to authenticate the remote computer and allows it to authenticate the user, ensuring a secure connection. Let us understand how SSH keys work. SSH keys come in pairs, a private key and a public key. The private key stays on your local machine and should never be shared with anyone. It is used to decrypt messages. The public key, on the other hand, is shared with Git servers and added to your account. It's used to encrypt messages. Here's how the process works. First, you generate a key pair on your computer. Then you add the public key to platforms like GitHub or GitLab. When you try to connect, the server verifies your identity using these keys. If everything matches, access is granted without the need for a password. To generate a new SSH key pair, use the command ssh-keygen, followed by the parameter t@25519, and followed by your email address at example.com. This command creates a modern, secure, and faster key using the ed25519 algorithm. If ed25519 is not supported, you can use RSA by typing ssh-keygen, followed by the parameter trsa, b4096, and followed by your email at example.com. Remember to use a strong passphrase for additional security. The default location for the private key is ~ssh/id_ed25519, and the public key will be saved as ~ssh/id_ed25519.pub. The SSH agent is a program that holds private keys used for SSH authentication, eliminating the need to enter your passphrase every time you use your SSH key. To start the SSH agent in the background, use the command eval followed by the output of ssh-agent-s inside parenthesis. This command will give you an agent process identification. To add your SSH private key to the agent, type ssh-add, followed by ~ssh/id_ed25519. This adds your identity to the agent. To add your SSH key to GitHub, first, copy your public key to the clipboard using the cat command followed by ~ssh/id_ed25519.pub and pipe it to clip for Windows, pcopy for macOS, or xclip for Linux. Then go to your GitHub account settings and select SSH and GPG keys from the sidebar. Click the new SSH key button, give your key a descriptive title, paste your public key into the key field, and click Add SSH key to save. To test your SSH connection to GitHub, use the command ssh-tgit at github.com. You may be asked to confirm the authenticity of the host the first time. If you see the message "Hi username!", you've successfully authenticated, but GitHub does not provide shell access. Your SSH key is working. The shell access message is normal, as GitHub doesn't provide shell access. To clone a repository using SSH, use the command git clone git at github.com:/repo.git. For example, git clone git at github.com:/user/project.git. To change a remote URL from HTTPS to SSH, use the command git remote set-URL origin git at github.com:/username/repo.git. You can verify the change by typing git remote-v. When copying repository URLs from GitHub, you can toggle between SSH and HTTPS formats using the drop-down menu next to the URL field. If you encounter a permission-denied public key error, verify that your SSH key is added to the SSH agent and that your public key is added to GitHub. If you get an authentication failed error, ensure you're using the correct SSH key and that the SSH agent is running. For host key verification failed, remove the problematic host from known hosts by running the command ssh-keygen- or github.com. Finally, if you're using HTTPS instead of an SSH URL, change the remote URL to the SSH format by running the command git remote set-URL origin git at github.com:/user/repo.git. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. In this lesson, we will explore Git credential helpers. Git credential helpers securely store your credentials for seamless Git operations. Let's understand the problems with Git authentication. One of the common authentication challenges is repeatedly entering credentials for every Git operation. Secondly, storing passwords in plain text is insecure. Authentication tokens expire, requiring frequent updates. Finally, different authentication methods exist across various Git hosts. Git credential helpers offer a solution to these problems. Git credential helpers are mechanisms that securely store and retrieve your authentication credentials, eliminating the need to manually enter them for each Git operation. There are mainly two types of Git credential helpers. First, built-in helpers which come with Git installation, including cache, store, and platform-specific options. Second, external helpers, which are third-party solutions that integrate with system keychains and password managers. Let's explore built-in Git credential helpers. The first one is cache. It temporarily stores credentials in memory for a configurable timeout period. To configure it, use the command git config global credential helper cache timeout equals 3600. The second one is store. It stores credentials in a plain text file on disk, making it less secure. To configure, use the command git config global credential.helper store. Let's take a look at platform-specific credential helpers. For Mac operating system, there is macOS Keychain, which securely stores credentials in the macOS keychain. To configure it, use the command git config global credential helper OSCSkychain. For Windows operating system, there is Windows Credential Manager which integrates with Windows Credential Manager. To configure it, use the command git config global credential helper Winkard. For Linux operating system, there is Linux Secret Service, which uses libsecret to store credentials in GNOME Keyring or KD Wallet. To configure it, use the command git config global credential helper libsecret. Let's see third-party credential helpers. The first one is Git Credential Manager, which is Microsoft's cross-platform credential helper with support for multi-factor authentication. You can install it via Package Manager. For example, on macOS, you can use the command brew install cast Git Credential Manager. The second one is passgit helper. It integrates with the Unix password manager named pass. To configure it, use the command git config global credential helper passgit helper at the rate. Please note that it requires pass to be installed and configured. Let's see a practical example of setting up a credential helper. To configure Git to use the appropriate credential helper for your platform, for macOS, use git config global credential helper OSCSkychain. For Windows, use git config global credential.helper Winkard, and for Linux with libsecret, use git config global credential helper libsecret. The first time you perform a Git operation requiring authentication, Git will prompt you for your username and password. After entering credentials once, Git will store them securely using the configured helper. Subsequent operations won't require authentication until credentials expire. Here are some best practices for using Git credential helpers. Use personal access tokens. Prefer tokens over passwords for better security and granular permissions. Set appropriate timeouts. For cache helper, balance convenience with security by setting reasonable timeouts. Avoid plain text storage. Use system keychains instead of the basic store helper when possible. Clear credentials when needed. Know how to remove stored credentials when changing accounts or tokens. Here are some further resources. Git documentation, GitHub Docs, Microsoft's Git Credential Manager documentation. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Let's explore Git with GitHub Command Line Interface, often called CLI. This tool helps you streamline your workflow by bringing GitHub's features directly to your command line. This allows you to manage your repositories, issues, and pull requests without needing to open your web browser. The GitHub CLI enhances efficiency by allowing you to perform GitHub tasks directly from your terminal. It also ensures seamless integration of your workflow with existing Git commands. It supports automation by allowing you to script and automate GitHub operations. Here are the steps for installing the GitHub Command Line Interface. The GitHub Command Line Interface is available for Windows, macOS, and Linux. For macOS using Homebrew, use the command brew install gh. For Windows using Scoop, use the command scoop install gh. For Debian or Ubuntu Linux, use the command sudo apt install gh. After installation, verify it with the command gh --version. For authentication setup, authenticate with your GitHub account by starting the login process with the command ghauth login. Follow the interactive prompts to select github.com, choose an authentication method, and authorize the command line interface. You will need to authorize GitHub CLI to access your GitHub account. Let's explore some basic GitHub command line interface commands. To view your repositories or repositories from a specific user, you can use the Listing Repositories command. To list your own repositories, you can type gh-repo list. To list repositories from a specific user, type gh-repo list username. Next, to view detailed information about a repository, use the Repository Information command. To view repository details, type gh-repo view owner/repo. To view a repository in the web browser, type gh-repo view --web. You can also create new repositories directly from the command line with the Creating Repositories command. To create a new repository, type gh-repo create repo name. To create a new repository with a description and set its visibility, type gh-repo create repo name --public --description and in quotes, write the description. You can also clone repositories with simplified commands. To clone your repository, type gh-repo clone repo name. To clone a repository from another user, type gh-repo clone username/repo name. GitHub Command Line Interface enables you to efficiently handle issues directly from your terminal. To list open issues in the current repository, type gh-issue list. To view a specific issue, type gh-issue view issue number. Remember that you can use the --web flag to open issues directly in your browser. To create a new issue from the terminal, type gh-issue create --title, and then the issue title in quotes followed by --body, and then the description in quotes. You can also close an issue using the command gh-issue close issue number. For a more detailed issue creation process, you can simply use the command gh-issue create without any flags to enter an interactive mode. Let's learn how to manage pull requests using the GitHub Command Line Interface. To create a pull request, use the command gh-pr create. For more control, you can add a title and body to your pull request using the command gh-pr create --title followed by the title in quotes, and --body followed by the description in quotes. The workflow for creating pull requests involves making changes in a feature branch, committing and pushing your changes, and then creating a pull request with the gh-pr create command. To list open pull requests, type gh-pr list. To view a specific pull request, type gh-pr view PR number. To check out a pull request locally, type gh-pr checkout PR number. The workflow involves reviewing pull request details with gh-pr view, checking it out locally to test changes, and then merging it with gh-pr merge when ready. Here's how you can manage gists and releases using the GitHub Command Line Interface. To create a gist from a file, you can type gh-gist create file.txt. To create a public gist with a description, you can type gh-gist create --public --description in quotes followed by file.txt. A common use case for gists is to quickly share code snippets or configuration files with your team without creating a full repository. To view your gists, use the command gist list. To create a new release, type release create v1.0.0. To create a release with notes and attached files, type release create v1.0.0 -notes in quotes followed by the release notes and then /dist.zip. The release workflow typically involves tagging your code, building distribution files, and publishing a release with attached assets, all from the command line. You can view all your releases with release list. Explore how to manage GitHub actions and workflows using the GitHub command line interface. To list all workflow runs, type workflow list. To view a specific workflow, type workflow view workflow name. The workflow typically involves creating a workflow file, triggering the workflow, and monitoring the results. To run a workflow manually, type workflow run workflow name. To view the workflow run status, type run list. To view the run details, type run view run ID. To monitor a workflow run in real time, use run watch. The workflow involves triggering the run, watching the progress, and then viewing the results. Let's see how to extend the functionality of the GitHub command line interface with extensions. To list available extensions, type extension list. To install an extension, type extension install owner/name. Remember that extensions are repositories that start with -. There are some popular extensions that are very useful. The first one is -, which provides an interactive dashboard for pull requests and issues. The second is repo explore, which allows you to explore GitHub repositories interactively. Then there is changelog, which is used to generate changelogs from pull requests. Finally, token helps you manage GitHub tokens securely. Let's discuss some best practices to optimize your workflow with the GitHub command line interface. Create aliases for frequently used commands to save time and keystrokes. You can configure these aliases in your shell profile or GitHub command line interface config. Use alias set to create custom shortcuts. Use secure shell keys for authentication when possible. For tokens, use the minimum required scopes and rotate them regularly for enhanced security. You can use auth status to check your current authentication method. Also, use issue and pull request templates to ensure consistent formatting. GitHub CLI respects repository templates when creating new issues and pull requests. You can store common templates locally for reuse with --template file. Combine GitHub CLI commands and shell scripts to automate repetitive tasks like release management, issue triage, or pull request reviews. Also, use the --JSON flag for structured output in scripts. To further your knowledge, refer to the official documentation, the GitHub CLI repository, and the community forums. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content. Hello everyone and welcome. Today we are diving into the world of GitHub Actions. GitHub Actions is a powerful continuous integration and continuous delivery platform that helps you automate your software development workflows. In this presentation, we'll cover the basics from understanding what GitHub Actions is to creating your very first workflow. So, what exactly is GitHub Actions? Well, GitHub Actions is a built-in continuous integration and continuous delivery platform directly integrated into GitHub repositories. It allows you to automate your software workflows, meaning you can automatically build, test, and deploy your code right within the GitHub infrastructure. GitHub Actions supports a variety of environments, including Linux, macOS, and Windows, making it versatile for different types of projects. Some common use cases include automated testing and building of your applications, continuous deployment and delivery so your code is always up to date, code quality checks, and even scheduled tasks and maintenance. Let's understand the structure of a GitHub Actions workflow. The workflow is triggered by an event, which then tells the runner to execute the workflow. The runner executes the job, which is a set of steps. Each step is an individual task and makes use of Actions, which is a reusable unit. On the right, you can see a basic structure of a GitHub Actions workflow file, typically named main.yml, and located in the .github/workflows directory. First, we define the name of our workflow, in this case, CI workflow. Then we define the event or events that will trigger the workflow, like a push or a pull request. Now let's go through the steps to create your first workflow. First, in your repository, create a directory named .github/workflows/. In this directory, you will add a YAML file that defines your workflow. Here's an example of a simple workflow file named hello-world.yml. The workflow is named Hello World Workflow and is triggered on a push event. The workflow contains a job named Hello, which runs on the latest version of Ubuntu. The job contains one step named Say Hello, which simply prints the message Hello, GitHub Actions, to the console. Let's explore some common event triggers that can start your workflows. The push event triggers the workflow when code is pushed to the repository. The pull request event triggers when a pull request is opened or updated. The schedule event allows you to run workflows at specific times using cron syntax. The workflow dispatch event enables manual triggering of the workflow, and the repository dispatch event is used to trigger workflows from external webhooks. Here's an example of a workflow file with multiple trigger examples. For push events, we can specify the branches that will trigger the workflow, such as main or develop, and also specify paths to ignore. For pull requests, we can specify the types of events that will trigger the workflow, such as opened or synchronized. For schedule events, we can define a cron expression to run the workflow daily at midnight. In GitHub Actions, a workflow contains jobs that run in parallel by default. Each job contains steps that run sequentially. Let's look at an example. Here is a jobs block. Within that, there is a job called build. The build job runs on the latest version of Ubuntu. The build job contains steps. First, it checks out the code, sets up Node.js, installs dependencies, and then performs the linting. Let's explore the different types of actions you can use in your workflows. Official actions are maintained by GitHub. Community actions are created by the community. Docker container actions run in Docker containers, and JavaScript actions run directly on the runner. Here's how to use actions in your workflow. First, we check out the repository using the action/checkout at v3action. Then we set up Python using the action/setup-python at v4action, specifying the Python version to use. Finally, we run tests using PyTest. Let's learn how to manage configuration and sensitive data in your workflows. Use environment variables for configuration and secrets for sensitive data such as API keys and passwords. Here's an example of how to use environment variables and secrets in your workflow. We define environment variables such as node environment and API URL at the job level. We define a secret called API token at the step level. Secrets are stored securely by GitHub and are not exposed in the workflow logs. Let's take a look at some advanced workflow features that can help you optimize your workflows. Matrix builds allow you to test your code across multiple configurations. Caching allows you to speed up your workflows by caching dependencies. Artifacts allow you to share data between jobs, and job dependencies allow you to control the execution order of your jobs. Here's an example of how to use matrix builds in your workflow. We define a matrix with node versions 14, 16, and 18. The workflow will run 3 times, once for each node version. Here are some resources to help you learn more about GitHub Actions and get started automating your workflows. First, the GitHub Actions official documentation and guides. Second, the GitHub Actions Marketplace, where you can explore thousands of pre-built actions. Third, starter workflows, which are templates for common continuous integration and continuous delivery scenarios. Thank you. Start automating your workflows with GitHub Actions. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Welcome. In this video, we will explore Git workflows. We'll understand different Git workflow models for effective collaboration. Let's dive in. So, what exactly are Git workflows? Git workflows are structured approaches that define how code changes flow through a project, how teams collaborate on shared repositories, branch management strategies, and release processes and deployment patterns. Why should you use structured workflows? Well, structured workflows provide many benefits, including consistency. They establish predictable patterns for code changes and integration, reducing confusion and errors during development. They enhance team collaboration by providing clear guidelines for how team members work together, reducing conflicts and improving coordination. Structured workflows also improve code quality by enforcing review processes and testing stages, ensuring higher quality code reaches production environments, and finally, they provide deployment reliability by creating stable release processes with clear paths from development to production, reducing deployment failures. Let's explore the centralized workflow. This workflow has a single main branch, usually named master or main. All developers commit directly to this main branch. This workflow is similar to the Subversion workflow model, and is best suited for small teams or simple projects. Let's look at a few commands for the centralized workflow. First, you clone the central repository using the command git clone, followed by the repository URL. Then you get the latest changes using git pull origin main. Next, you commit your changes with a message using git commit, and followed by the commit message. Finally, you push your changes to the central repository using the command git push origin main. Let's discuss the feature branch workflow. In this workflow, all feature development takes place in dedicated branches. The main branch never contains broken code. Pull requests are used for code review, and it enables parallel development. Here are some common commands in the feature branch workflow. You start from the main branch using git checkout main. Then you create and switch to a new feature branch using git checkout b feature/login. You can then work on the feature. To push the branch to remote, use command git push origin feature/login. After creating a pull request via GitHub or GitLab, you can update main after the merge using git checkout main and git pull. Let's discuss the Git flow workflow. This is a strict branching model for larger projects. It has two main branches, main and develop, and supporting branches, such as feature, release, and hotfix. It is designed for scheduled release cycles. Let's look at the different branch types. Feature branches branch from develop and merge back to develop. They are used for developing new features isolated from other work. Release branches branch from develop and merge to main and develop. They are used for preparing new production releases. Hotfix branches branch from main and merge to main and develop. They are used for quickly fixing critical production issues. Now let's discuss the forking workflow. In this workflow, every developer has their own server-side repository. Changes flow through pull requests. Project maintainers control what gets merged. It is ideal for open-source projects. It enables contribution without direct access. Let's look at the commands. First, you fork via GitHub or GitLab user interface. Clone your forked repository by using git clone followed by the URL. Add the original repository as upstream by using command git remote add upstream followed by the original project URL. Then you can create a feature branch by using git checkout b feature/new feature. Finally, push the changes to your forked repository by using git push origin feature/new feature. Then create a pull request to the original repository via the GitHub or GitLab user interface. Let's talk about trunk-based development. It uses a single branch, the trunk or main branch, short-lived feature branches, and frequent integration to the trunk. There is an emphasis on continuous integration and continuous delivery practices. Feature toggles are used for incomplete work. Now let's compare some advantages and challenges. The advantages are simpler branching strategy, reduces merge conflicts, enables continuous integration, and has faster feedback cycles. The challenges are it requires a strong testing culture, feature toggles add complexity, it needs an automated CI/CD pipeline, and team discipline is required. So, how do you choose the right workflow? Well, if you have a small team and simple projects, use the centralized workflow. If you need isolation for feature development with code reviews, use the feature branch workflow. If you have formal release cycles and need to maintain multiple versions, use the Git flow workflow. If you prioritize continuous integration and have strong automated testing, use trunk-based development. Here are some key decision factors to consider: team size and structure, release frequency, and testing maturity. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Hello everyone. Today we're diving into the Git feature branch workflow, a collaborative approach for modern development teams. This workflow is essential for managing code changes and ensuring a stable and reliable code base. So, what exactly is the feature branch workflow? It's a method where development is isolated in dedicated branches, ensuring the main or master branch never contains broken code. Feature branches are merged only after a thorough review. This enables parallel development, allowing multiple developers to work on different features simultaneously without interfering with each other. Let's walk through the basic steps of the feature branch workflow. Step 1. Start with main. Always begin by updating your main branch to the latest version. Use the command git checkout main followed by git pull origin main to ensure you have the most recent code. Step 2. Create a feature branch. Create a new branch for your feature with a descriptive name. For example, use the command git checkout-b feature/login to create a new branch named feature/login. Step 3. Work on the feature. Make changes and commit them frequently with clear messages. Use git add to stage your changes, and then git commit-m followed by your message, such as add login form, to commit your changes. Step 4. Push and create a pull request. Push your branch to the remote repository and create a pull request for review. Use the command git push origin feature/login to push your branch. Now let's discuss feature branch naming conventions. Following best practices is crucial for maintaining a clean and organized repository. Here are some key guidelines. Use descriptive prefixes to categorize branches. For example, use feature/ for new features, fix/ for bug fixes, and refactor/ for refactoring tasks. Include ticket or issue numbers for traceability. This helps link your branch to a specific task in your project management system. Use kebab case for readability. This means using lowercase letters and hyphens to separate words, such as user-authentication. Keep names concise but descriptive. Aim for branch names that are easy to understand at a glance. Avoid personal names and branch names to maintain consistency and professionalism. Here are some examples of good branch names. For a feature development, git checkout-b feature/user-authentication or feature/jira-123-payment-gateway. For bug fixes, git checkout-b fix/login-timeout or bug fix/456-header-alignment. And for refactoring, git checkout-b refactor/API-client. Let's delve deeper into working with feature branches. First, create and switch to a new feature branch using the command git checkout-b feature/user-profile. Next, make your changes and commit them using git add, followed by git commit-m, and a descriptive message like add user profile page. Then, push the branch to the remote repository with the command git push-u origin feature/user-profile. Finally, switch back to the main branch using git checkout main. Remember, it's always best practice to create a new branch for each feature or bug fix to keep your work isolated and organized. It's essential to keep your feature branches updated to avoid merge conflicts and ensure your code is based on the latest changes. Here's how to do it. First, commit or stash your changes to save your work temporarily. Second, switch to the main branch and pull the latest changes using git checkout main, followed by git pull origin main. Third, return to your feature branch using git checkout feature/user-profile. Fourth, merge or rebase your feature branch with main using git merge main or git rebase main. This diagram illustrates how the main branch and feature branch evolve and how to merge or rebase to keep them in sync. Let's compare merge versus rebase, two common strategies for integrating changes. Merge preserves the history exactly as it happened and creates a merge commit. It is a non-destructive operation and is generally better for public or shared branches. Rebase, on the other hand, rewrites commit history and creates a linear history, resulting in a cleaner project history. It is better suited for private or local branches. Here are the commands for each approach. For merge, use git checkout feature/user-profile, followed by git merge main. For rebase, use git checkout feature/user-profile, followed by git rebase main. If conflicts occur during rebase, you can use git rebase --continue to resolve them or git rebase --abort to cancel the rebase. Pull requests and code reviews are crucial for maintaining code quality and collaboration. Here is how you create a pull request. First, push your feature branch to the remote repository. Second, navigate to your repository on GitHub, GitLab, or Bitbucket. Third, create a new pull request from your feature branch to main. Fourth, add a descriptive title and detailed description. Fifth, assign reviewers and add relevant labels. Here is a code review checklist to ensure high-quality submissions. Code follows project style guidelines. All tests pass successfully. Code is well documented with comments. There is no debugging code or console logs. Changes are focused on the feature scope. The pull request description clearly explains what and why, and the branch is up to date with the main branch. Now let's look at the process of merging feature branches. First, ensure all code reviews are complete and approved. Second, verify all continuous integration and continuous delivery checks are passing. Third, update your feature branch with the latest main. Fourth, merge the pull request on GitHub or GitLab. Fifth, delete the feature branch after a successful merge. Here's how to do it from the command line. First, update the main branch with git checkout main followed by git pull origin main. Second, merge the feature branch locally with git merge feature/user-profile. Third, push changes to the remote with git push origin main. Fourth, delete the feature branch with git branch-d feature/user-profile and git push origin --delete feature/user-profile. Remember to always ensure your main branch is protected with required reviews. Let's wrap up with some best practices and a summary. First, keep branches short-lived to minimize merge conflicts. Aim to complete and merge features within a few days rather than weeks. Second, use descriptive commit messages that explain what changes were made and why. This helps with code reviews and understanding history later. Third, test before merging. Always run tests locally before creating a pull request. Ensure CI/CD pipelines pass before merging to maintain code quality. Fourth, clean up after merging. Delete feature branches after they have been successfully merged to keep the repository clean. This prevents confusion and working on outdated branches. In summary, the feature branch workflow enables teams to collaborate effectively while keeping the main branch stable. By isolating work in dedicated branches, Teams can develop features in parallel without affecting each other, leading to higher quality code and smoother releases. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. Welcome to this video on Git-Flow workflow. Git-Flow is a structured branching model designed to enhance team collaboration and streamline release management. Let's explore how it can improve your development process. Git-Flow is a branching model for Git that provides a structured framework for managing larger projects. It was created by Vincent Driessen in 2010, defining specific branch roles and rules. Git-Flow is optimized for planned release cycles, providing a clear separation between development and production code. It helps teams manage features, releases, and hotfixes in an organized and efficient manner. In Git-Flow, the foundation consists of two core branches: master and develop. The master branch contains production-ready code. All code in this branch should be stable and ready for release. It represents the official release history, where each commit signifies a production release. Direct commits to master are restricted. The develop branch is where ongoing development takes place. It serves as the integration branch, containing the latest development changes. Feature branches are branched off from here, making it the bleeding edge of the project. Feature branches are used to develop new features for upcoming or future releases. They always branch from the develop branch, allowing for isolated development of individual features. The naming convention for these branches is typically feature/feature name. Once a feature is complete, it is merged back into the develop branch. Feature branches usually exist only in developer repositories, ensuring a clean and organized central repository. Release branches support the preparation of a new production release. They branch from the develop branch and merge into both master and develop. The naming convention is typically release/x.y.c. Only bug fixes, documentation, and release-oriented tasks are allowed in release branches, with no new features introduced at this stage. Hotfix branches are used to quickly patch production releases. They are unique as they fork directly from the master branch. When a critical bug is identified in production, a hotfix branch is created to address it. This branch merges back into both master and develop after the fix. The naming convention for hotfix branches is usually hotfix/x.y.c. Hotfix branches have a higher priority than other branches as they address critical issues in the production environment and creates a new version tag. Git-Flow provides a set of commands to streamline the workflow. To start, initialize Git-Flow if you haven't already. Then initialize the repository. For feature branches, use Git-Flow feature start name to begin a new feature, and Git-Flow feature finish name to complete it. Similarly, Git-Flow release start version and Git-Flow hotfix start version are used to start release and hotfix branches, respectively. Without the Git-Flow extension, use git checkout develop, and then git checkout b feature/name for new branch creation, followed by a merge using git merge noff feature/name. To make the most of Git-Flow, adopt the best commit practices by writing meaningful commit messages, keeping commits focused, and committing regularly. In branch management, delete branches after merging, use descriptive branch names, and keep feature branches short-lived. Implement code reviews before merging to develop using pull or merge requests and enforce review standards. To ensure smooth collaboration, document the workflow for the team, communicate branch creations, and coordinate release schedules. Git-Flow offers a clear separation between development and production code, parallel development with minimal conflicts, structured release management, a well-defined process for hotfixes, and it's excellent for planned release cycles. However, it can be complex for small projects, add overhead for continuous delivery models, has a steeper learning curve for Git beginners, is less flexible for rapid iteration cycles, and may slow down development in some contexts. Use GitFlow for projects with scheduled release cycles, teams with dedicated quality assurance processes, software that requires version maintenance, and larger teams with multiple contributors. As alternatives to GitFlow, GitHub Flow offers a simpler workflow focused on continuous delivery, where features branch from main and merge back after review. GitLab Flow combines feature branches with environment branches, adding production and pre-production branches. Trunk-based development emphasizes small, frequent commits to the main branch. In summary, GitFlow provides a robust branching model for projects with scheduled release cycles. It is ideal for teams with planned releases as it provides clear processes for all scenarios. Choose the workflow that best fits your project's specific needs. Some further resources are Atlassian GitFlow tutorial, GitFlow cheat sheet, and Vincent Dreesen's blog. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content. In this video, we will be learning about the Git forking workflow, which is a common method for contributing to open source projects. This workflow allows you to make changes to a project without directly affecting the original repository. Here's how it works. First, you fork the original repository. This creates a copy of the repository in your own account. Then, you clone your fork to your local machine. This creates a local copy of the repository that you can work on. After making changes locally, you push them back to your remote fork. Finally, you submit a pull request to the original repository, asking the maintainers to merge your changes. This collaborative approach enables contributions from various developers while maintaining the integrity of the main project. Let's begin our dive into Git forking. So, what exactly is forking? Think of a fork as your personal copy of a repository. It allows you to freely experiment with changes without affecting the original project. Forking is an essential process when you want to contribute to open source projects. This process creates a connection between your fork and the original repository, allowing you to propose changes through pull requests. Here are the steps to get started. First, navigate to the repository you're interested in on GitHub. Second, click the fork button, usually found in the top right corner of the page. Third, clone your fork locally using the command git clone followed by the repository's URL. Remember to replace your username with your actual GitHub username and repository name with the name of the forked repository. Finally, navigate to the project directory using the cd command followed by the repository name. Now that we have a forked repository, let's set up the remote connections. When working with a fork, it is important to set up two remote connections, origin and upstream. Origin refers to your fork, and this is automatically set up when you clone the repository. Upstream refers to the original repository, and you will need to add this manually. To add the upstream remote, first check the current remotes using the command git remotev. You will see the origin remote URL for fetching and pushing. Next, add the upstream remote using the command git remote add upstream followed by the original repository's URL. Make sure to replace original owner and repo with the correct values. Finally, verify the new remote by running git remotev again. You should now see both origin and upstream listed. Let's talk about creating a feature branch. It is always best to create a new branch for each feature or bug fix you're working on. You should also use descriptive branch names such as feature, fix, or docs to indicate the purpose of the branch. Ensure your main branch is up to date with the upstream repository before branching. Here's how to create a feature branch. First, make sure you're on the main branch by running the command git checkout main. Next, sync with the upstream repository to get the latest changes. Use the command git fetch upstream to fetch the latest changes from the upstream repository, and then use the command git merge upstream /main to merge those changes into your local main branch. Finally, create and switch to a new branch using the command git checkout, be followed by the name of your new branch. For example, feature/awesome feature. Now let's discuss making changes and committing them. While working on your feature branch, make the necessary changes to implement your feature or fix a bug. Follow the project's code style guidelines to ensure consistency. Write clear, atomic commits, and use descriptive commit messages to explain the purpose of each commit. Remember to test your changes thoroughly to ensure they work as expected. To commit your changes, first check the status of your changes using the command git status. This will show you which files have been modified. Next, add the specific files you want to include in the commit, using the command git add followed by the file path. Alternatively, you can add all changes using the command git add. Finally, commit your changes with a descriptive message using the command git commit, followed by your message in quotes. For example, add user authentication feature. After making and committing your changes, it's time to push them to your fork on GitHub. Remember to always push to your fork, not directly to the upstream repository. Use the same branch name on the remote repository as your local branch to keep things organized. To push your changes for the first time, use the command git push, origin followed by your branch name. For example, feature/awesome feature. The U option sets up upstream tracking, which makes future pushes easier. For subsequent pushes, you can simply use the command git push. If you need to force push, which should be used with caution, use the command git push, force with lease origin followed by your branch name. Now that you have pushed your changes to your fork, you can create a pull request to propose your changes to the original repository. First, navigate to your fork on GitHub. Next, click the Pull Request button. Select the base repository and branch, which is the original repository and the branch you want to merge your changes into. Select your head repository and branch, which is your fork and the branch containing your changes. Write a clear title and description for your pull request, explaining the purpose of your changes. Reference any related issues in the description to provide context. This step initiates the process of merging your code into the original project, pending review and approval from the maintainers. After submitting your pull request, it's important to handle any feedback you receive from the maintainers. Be responsive to their comments and suggestions, and make any requested changes in the same branch. Push the updated changes to your fork, and the pull request will update automatically. Address all feedback before the pull request is merged. To update your pull request, first make sure you're on your feature branch by running git checkout followed by the branch name. Make the requested changes, then stage and commit those changes using git add, and git commit them with a descriptive message. Finally, push the updates to your fork using git push. To summarize, the forking workflow involves forking the original repository, cloning your fork locally, adding the upstream remote, creating feature branches, pushing changes to your fork, creating pull requests, and addressing feedback. Now, for some best practices. Keep your fork updated with the upstream repository to avoid conflicts. Work on one feature or fix per branch to keep your changes focused. Write clear commit messages to explain the purpose of your changes. Follow the project's guidelines for code style and conventions. Be responsive to feedback from the maintainers, and clean up your branches after they have been merged to keep your repository organized. Following these practices ensures smooth and effective contributions to open source projects. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.